For a long time, we have believed that humans are the first and only intelligent beings to live on Earth, building cities, inventing technology, and sending machines into space. But what if that idea isn't the full story? What if, long before us, another advanced civilization lived on this planet, smart, powerful, and now completely gone? Is it possible that something rose and fell millions of years ago, leaving behind strange objects, tools, carvings, or buildings we don't understand? Could the Earth have quietly hidden their story under layers of time, just waiting for someone to ask the right question? Before we explore all this, let us know where in the world you're watching from, and what time it is for you right now. Drop it in the comments below and settle in for a fascinating journey. The Silurian hypothesis is a bold and fascinating idea that challenges everything we think we know about human history. It asks a deep and surprising question. What if human beings are not the first intelligent civilization to rise on Earth? What if, millions of years before us, there was another advanced society, one that built technology, explored science, and maybe even reached for the stars, only to vanish completely, leaving behind little or no trace? This hypothesis was introduced by two scientists, astrophysicist Adam Frank and planetary scientist Gavin Schmidt. They wondered whether Earth might have once been home to intelligent life forms long before humans ever appeared. If such a civilization existed, could all signs of their presence have been wiped away by nature itself? By volcanic eruptions, earthquakes, erosion, rising seas, or changes in climate over tens of millions of years? Unlike traditional archaeology, which focuses on the rise of human civilizations over the past few thousand years, this idea stretches far beyond our known history. It dares us to consider that civilization itself might not be unique to humanity. Perhaps it is something that has happened more than once during Earth's 4.5 billion year history. At the heart of this hypothesis is a simple but powerful idea. Maybe humans are not the first, and maybe we are not the only intelligent life to walk this planet. If another civilization once existed millions of years ago, most of their buildings, cities, and machines would likely have crumbled away. Natural processes, like shifting tectonic plates, rising mountains, eroding coastlines, and even asteroid impacts, could have erased nearly all signs of them. That's why scientists looking into this possibility aren't just searching for statues or ruins. Instead, they're hunting for more subtle, indirect clues. These might include unusual chemical traces buried in rocks, strange layers in ancient sediments, or odd patterns in the Earth's isotopes, tiny atomic fingerprints that might suggest past industrial activity. Finding such hints is difficult, but not impossible. The big problem is that Earth's geological record, the layers of rock and sediment that tell the story of our planet, is incomplete. Over millions of years, much of it gets crushed, melted, or recycled by nature. Regular archaeology depends on objects like tools, pottery, and bones, things that rarely survive beyond a few 100,000 years. So, if a civilization lived on Earth, say 50 million years ago, almost everything they built would be gone. That's why the Silurian hypothesis encourages a different approach, one that brings together many branches of science. It's not just about digging up old objects, it's about combining geology, chemistry, climate science, and even computer simulations to search for deeper clues buried in Earth's history. This theory doesn't just challenge how we search for the past, it also asks us to rethink what we mean by civilization. It opens up big questions. How long can a technological society survive? Do civilizations rise and fall like waves over time? Could our own be one in a long series of many? And what happens when a civilization collapses? Does it leave any mark that survives? Exploring these questions forces us to rethink not just the past, but also the future. If other intelligent species once lived on Earth, and if they vanished without a trace, what might that say about us? Thinking about civilizations that might have existed before humans isn't just science fiction. It has real value for scientists and archaeologists. It helps us question long-held assumptions and expand our understanding of how life and intelligence evolve over time, For a long time, historians and scientists believed that civilization followed a straight path. Early humans formed tribes, then cities, then built machines, and finally reached the modern world. This story made it seem like humans were the only ones ever capable of creating complex societies and advanced technology. But the Silurian hypothesis flips that idea on its head. If a civilization rose and fell millions of years ago, we might not find stone buildings or metal tools. Instead, we would need to look for subtle signs, like strange chemical residues, odd rock patterns, or even unexpected minerals that might suggest industrial processes. These traces might be buried deep underground or hidden in the ocean floor. Finding such signs would be one of the biggest discoveries in human history. It would force us to rewrite everything we know about life on Earth. It would also raise new questions. How long did that civilization last? What caused it to collapse? Could the same thing happen to us? And there's another layer to this story, one that goes beyond science. The idea that humans might not be the only intelligent beings ever to live on Earth shakes up our sense of importance. For centuries, people have believed that we are the center of everything. From ancient religious teachings to Enlightenment science, humanity has often been seen as unique, special, even destined to rule the world. This belief was reinforced by the complexity of human language, culture, and technology. It made it seem unlikely that any other species, on Earth or elsewhere, could match our intelligence. And because we've never found strong evidence of alien civilizations or pre-human ones, many assumed they didn't exist. But as our tools grow more advanced, and as we learn more about the history of our planet, that confidence is beginning to fade. New discoveries in fields like astrobiology, planetary science, and deep-time geology suggest that we may have been too quick to dismiss other possibilities. The Silurian hypothesis encourages us to be open-minded. It reminds us that intelligence might not look like we expect. It could arise in forms and places we've never imagined. And if civilizations can come and go, here on Earth or out in the stars, it's worth asking, what will future beings think of us? Will we leave behind anything they can find? The belief that humans are special has been with us for a very long time. During the Renaissance and the Enlightenment, roughly between the 15th and 18th centuries, science began to flourish. People started using careful observation and logical thinking to understand the world. But even as knowledge grew, many still saw humans as the center of everything. Back then, people believed Earth was the center of the universe, a view known as the geocentric model. Even when that idea was proven wrong, another belief took its place, that humans were the most intelligent and important species in the universe. Our ability to build cities, speak languages, and develop advanced technologies seemed to prove it. Some of these beliefs also came from religious or philosophical ideas. Many thought humans were specially created, set apart from all other creatures. Others believed that if intelligent life existed elsewhere, it would either be very different or far less advanced than us. Another reason people believed in human uniqueness was the lack of evidence for anything else. We hadn't found any signs of alien civilizations, nor had we found clear proof of intelligent life on Earth before us. From a scientific point of view, this possibility pushes researchers to look more carefully at the clues left behind in rocks, fossils, and ancient layers of the Earth. Our current tools, like radiometric dating and stratigraphy, which studies the layers of the Earth, are designed to detect natural changes over time. But what if there were traces of advanced technology buried deep underground? Signals so faint or so unusual that we simply overlook them, or mistook them for something natural. Scientists may need to go back and examine the fossil record, layers of sediment and chemical compositions in a new way, looking for things that might have been built or shaped by intelligent hands. These signs could be tiny, hidden, or damaged by time. Over millions of years, metal might rust away, buildings might be crushed or buried, and only strange patterns or chemical leftovers would remain. The big question is, could the remains of a long-lost civilization be hidden so deeply or eroded so badly that we can no longer recognize them? From a philosophical standpoint, the idea is just as powerful. If intelligent life once rose and fell on Earth before us, it would mean we're not necessarily the first or the only beings to reach a high level of knowledge and technology. That thought humbles us. It suggests that perhaps the rise of intelligence is not a rare miracle, but something that could happen again and again when the right conditions come together. It also makes us think more deeply about the nature of progress. Are civilizations like ours a natural outcome of evolution on Earth-like planets? Or are they rare and fragile, doomed to collapse after reaching a certain point? Could it be that other civilizations once existed here, achieved great things, and then vanished, leaving behind only hints that we're just now beginning to consider? This idea also raises important questions about how long technology can last. Would the machines, tools, or buildings of an ancient civilization survive for tens of millions of years? Or would nature destroy them so completely that we would never even know they were there? If an ancient civilization changed the Earth's climate or left behind chemicals in the soil, could we detect those changes today? All of this ties into bigger ongoing conversations about life beyond Earth. The Silurian hypothesis, a name given to this idea by scientists Adam Frank and Gavin Schmidt, connects the possibility of ancient Earth civilizations with the search for intelligent life elsewhere in the universe. It opens up exciting questions. If ancient intelligent life once existed on our planet, could other planets also have gone through similar cycles? Could life appear, rise to greatness, and disappear again and again throughout the galaxy? The hypothesis makes us look differently at both archaeological mysteries and stories from ancient cultures. For example, what if the strange leaps in ancient technology or the sudden appearance of complex knowledge in early societies were echoes of something older? Could myths of lost worlds like Atlantis or Lemuria be distant memories of real places that once existed, civilizations so old that they were forgotten by history? The Silurian hypothesis also encourages scientists to study ancient ruins and puzzling artifacts more carefully. Are some of these things really just the work of early humans? Or could they be misunderstood remains of something much older, perhaps even non-human? This idea challenges the traditional belief that all stories of gods, sky people, or vanished cities are just myths. What if some of them are based on real events from a time long before our own? Ancient cultures such as the Sumerians and Egyptians offer stories that hint at this possibility. The Sumerians, one of the oldest known civilizations, believed that their knowledge came from gods who descended from the sky. The Egyptians spoke of a time of chaos that was brought into order by divine beings, ideas that suggest something existed before humans, or at least before known history. On the other hand, many traditional stories describe history as starting with human beings, and moving in a straight line of progress from simple to advanced. Religious texts often describe a moment of divine creation, after which human history begins, leaving no room for earlier intelligent life. These stories seem to reject the idea of civilizations before our own. Still, there are legends and mysterious archaeological discoveries that keep the debate alive. Plato's famous story of Atlantis describes an advanced society that vanished beneath the sea. While many scholars see it as symbolic, others wonder if it could be based on a real place lost in time. Monumental structures like the Great Pyramids of Egypt or Stonehenge in England raise similar questions. Did ancient people really build them with the tools we think they had? Or did they inherit knowledge from a much older, forgotten source? Mainstream scientists are often cautious and prefer to see these ancient stories as myths or metaphors, not literal history. But the Silurian hypothesis invites us to stay open-minded. Instead of ignoring ancient tales or unexplained findings, perhaps we should take another look, with better tools and fresh thinking. To carefully test the idea behind the Silurian hypothesis, the suggestion that an advanced civilization may have existed on Earth long before humans, scientists turn to three major fields: geology, paleontology, and archaeology. Each of these scientific disciplines brings a different set of tools and knowledge to help us explore the incredibly long and complex history of our planet. Geology is the first and most fundamental field. Geologists study the layers of rocks, the minerals they contain, and how these layers are arranged over time. This gives us a timeline of Earth's past that stretches back for billions of years, far beyond anything written in human records. One of the most powerful tools geologists use is radiometric dating, which helps them figure out how old rocks are. For example, they can examine volcanic ash trapped between rock layers and use isotopes, tiny versions of elements that change over time, to tell exactly when that ash fell. This lets scientists build a reliable timeline of Earth's events. Now, imagine they discover something strange buried deep in the Earth, unusual mineral layers, massive disruptions in ancient rocks, or signs that something extremely hot once passed through. These oddities, if they don't match known natural processes, could be clues, hints that perhaps, long ago, some intelligent beings might have done something on this planet that left a trace. Paleontology, the study of ancient life through fossils, adds another piece to the puzzle. Paleontologists usually look at how life has changed and evolved by studying bones, shells, and imprints left in stone. But they also keep an eye out for anything odd, like a sudden change in fossil types, or something buried in a sediment layer that doesn't seem to belong, such as tiny manufactured-looking objects or materials with strange patterns. If these are not natural, they could suggest that intelligent life may have existed long before us, and left behind clues of their technology or impact. Archaeology, often thought of as the study of ancient human civilizations, can also look much deeper into the past when it turns its focus to very old, unexplained objects or materials. Modern tools like spectroscopy, electron microscopes, and chemical analysis help archaeologists figure out if a material was made naturally or created by intelligent beings. If scientists ever discover strange metals, unique alloys, or synthetic compounds in ancient rocks, especially in layers dating back millions of years, it might suggest the work of a long-lost civilization. These three fields, geology, paleontology, and archaeology, come together to form a powerful, multidisciplinary way of looking for signs of ancient civilizations. By combining rock timelines, fossil records, and possible artifacts, scientists look for patterns that don't make sense under current theories. And because this method uses multiple types of evidence, it helps make sure that any claims of a past advanced civilization are supported by strong scientific proof, not just wild guesses. If such proof ever did appear, it would mean we'd have to seriously rethink everything we thought we knew about life on Earth. The scientific process is designed to be very careful and skeptical, making sure any unusual discovery is not just the result of natural processes. But if something truly unexpected were found, something that points to a real, intelligent civilization from long before humans, it would be one of the most important discoveries in all of science. If the Silurian hypothesis turned out to be true, and we learned that a civilization as advanced as ours, or even more advanced, existed on Earth millions or even hundreds of millions of years ago, it would completely change how we see ourselves. Right now, most people believe that humans are the first and only species on Earth to build cities, create technology, and explore space. But if another intelligent species had already done something similar long ago, it would show that advanced life might not be as rare as we think. It could mean that the forces of evolution may have produced smart, tool-using beings more than once on this planet. This would also make us question just how stable and safe our planet really is. If an earlier civilization once existed and then disappeared, perhaps because of war, climate change, or a natural disaster, what does that say about our future? Could the same thing happen to us? If they changed the planet's surface by mining, building huge structures, or causing environmental damage, and that damage can still be seen today, it would suggest Earth remembers what we do for a very long time. It would raise serious questions about how long civilizations like ours can survive, and how carefully we need to treat the world we live in. In addition, proving this hypothesis could change our ideas about how long Earth has been a suitable home for life. It might suggest that Earth has gone through cycles, times when it supports complex life, and times when it resets due to catastrophe. That means civilizations could rise, fall, and disappear entirely, only to be replaced by others much later. These ups and downs would force scientists to look again at how Earth's climate, ecosystems, and life forms respond to major changes, and how often. What if an advanced civilization once lived on Earth long before humans, and all that's left of it are faint clues buried deep in the ground? Unlike modern humans, who leave behind buildings, roads, and machines, such a long-lost civilization might have vanished so completely that we would only find the faintest traces, clues hidden in the rocks, sediments, and minerals beneath our feet. To uncover these traces, scientists must look very closely at the Earth's geological layers, like detectives searching for a mystery buried in time. Geology, the study of Earth's layers, and related sciences like archaeology and chemistry can help us find possible evidence. But instead of clear signs like ancient tools or monuments, we might only find strange patterns in the way soil and minerals were deposited. These patterns are small and subtle, but they could tell us if something unusual once happened, something caused not by nature, but by intelligent beings. One of the biggest clues is found in sediment layers. Normally, over thousands or millions of years, dirt, sand, and other particles settle into layers. But sometimes, these layers don't look normal. They're too thick, mixed up, or made of strange materials. That can be a sign of something unnatural. Maybe large machines moved the Earth, or a civilization mined and reshaped the land. For example, if we find layers full of processed materials, like metal particles, building waste, or synthetic substances that don't belong in nature, it could mean someone was once living and building there. These materials might include special metal mixtures, alloys, or waste from factories, things that nature doesn't make on its own. Another important clue comes from chemistry, especially when scientists look at isotopes. Isotopes are versions of chemical elements with different weights, and they usually appear in natural ratios. But if these ratios are suddenly off, say, there's too much of one kind of lead or copper, it might mean that something or someone was messing with them. That someone could be a civilization using technology, like metalworking or chemical processing. These shifts in isotopic ratios act like chemical fingerprints, showing that something unusual happened in that location. If found in the same place as strange sediments or odd minerals, they build a stronger case that something artificial might have occurred long ago. Minerals can also carry important secrets. Natural processes usually create minerals in predictable ways, but sometimes scientists find minerals that look like they were formed under extreme heat or pressure, not from volcanoes, but possibly from furnaces, kilns, or factories. Imagine finding early ceramics or melted rocks stuck inside ancient sediments. Those could be leftovers from old technologies, like pottery or smelting. Some minerals might even look like industrial waste, such as slag or fused glass, which wouldn't naturally form in that environment, unless someone had created them. When we put all these clues together, strange sediment layers, unusual isotopes, and weird mineral formations, they begin to tell a story. It's like reading a hidden chapter of Earth's history, one that may point to a forgotten civilization. But this kind of research is tricky. Earth has changed a lot over the last several billion years. Volcanoes have erupted, continents have shifted, oceans have risen and fallen, and meteorites have smashed into the ground. All these events can bury or erase evidence, or even make natural things look like they were created by intelligent life. One of the biggest problems is that nature can sometimes make things that look like human artifacts. For example, certain minerals might form patterns that resemble tools or structures. Without context, it's easy to make a mistake and think something natural is man-made, or miss a real artifact because it's too damaged or hidden. Real evidence of ancient civilizations might be so worn down or buried so deep that it's hard to recognize. Some artifacts may have chemically changed over millions of years. That's why scientists have to be very careful. They use advanced techniques like high-resolution imaging, chemical testing, and stratigraphic analysis, studying rock layers, to figure out whether something is natural or artificial. This work often brings together many fields, geology, archaeology, chemistry, and even physics, to piece together the puzzle. Earth has also gone through major disasters. Massive volcanic eruptions, asteroid impacts, and sudden climate changes can destroy entire regions. These events could have wiped out any early civilization and buried whatever evidence they left behind under thick layers of ash or rock. Sometimes, these disasters even create confusing signals. For instance, a layer of volcanic ash might look like a man-made concrete floor, or melted rocks from an asteroid impact might resemble industrial waste. Scientists must untangle these clues to find out what really happened. Fortunately, today's scientists have powerful tools to help them. They can use satellite images, 3D scans of rock layers, and isotopic dating to look deep into Earth's past. Radiometric dating, for example, helps tell how old a layer of rock or sediment is, sometimes down to the exact year, even if it's hundreds of millions of years old. These tools help experts figure out if something unusual in the geological record is due to nature, or possibly the work of intelligent beings. One especially interesting place to search is in and around old impact craters. When a giant asteroid or comet hits the Earth, it makes a huge crater and sends debris flying everywhere. These craters can preserve unusual materials, like melted rock, glassy minerals, or rare metals, for hundreds of millions of years. If a civilization had existed during the time of an impact, the debris from that civilization might be buried along with the asteroid fragments. For example, if scientists found processed metals or synthetic materials in the same layer as an ancient impact, it could hint that intelligent life was around when the event happened. Sometimes, nature itself can help preserve the secrets of the past, especially when something dramatic happens to the planet. Huge volcanic eruptions or powerful earthquakes can completely change landscapes and bury everything in their path. These kinds of events don't just destroy, they also help preserve. When a supervolcano explodes, for example, it can spread ash across entire continents. This thick layer of ash settles and becomes part of the rock layers deep underground. Scientists can trace these ash layers across different parts of the world, almost like reading pages in a giant book of Earth's history. Now, imagine if an ancient civilization had existed before or during one of these massive eruptions. Their tools, buildings, or even traces of their presence, like changes in soil or strange chemical patterns, might have been buried under all that ash. Over tens of thousands or even millions of years, those layers could harden and protect whatever is trapped beneath them, keeping evidence of forgotten technologies safely hidden inside the Earth's crust. Planet-wide disasters like asteroid impacts or violent geological shifts can also affect the climate. These changes might speed up the decay of certain materials, but they might also create perfect conditions for preserving them. For example, the extreme heat and pressure caused by a giant impact could form very unusual minerals. If scientists ever find those minerals in strange places, especially alongside other odd discoveries, it might be a sign of something more than just natural activity. It might point to the presence of a civilization that came and went long before humans. As we dig deeper into Earth's past, these natural disasters start to look like both destroyers and time capsules. They can wipe out civilizations, but also freeze pieces of their world in time. That's why many researchers are asking new questions. Could the sediments at the bottom of the oceans or the layers of ancient ice near the poles hold hidden clues? Could these natural archives contain traces of a high-tech civilization that vanished long before recorded history began? Deep-sea sediments and thick ice cores are like Earth's memory banks. They hold information about our planet's environment going back hundreds of thousands to millions of years. These natural records offer scientists a unique way to look far beyond the reach of archaeology or written history. If any advanced society once walked the Earth long before humans, these hidden archives might be the best places to find proof. At the bottom of the oceans, sediments build up slowly over time. These layers contain a mix of mineral dust, bits of dead organisms, and microscopic fossils. Buried in this mix, researchers might find strange chemicals, rare minerals, or unexpected metals. For example, very high levels of gold, platinum, or rare earth elements, much more than what would occur naturally, could suggest activities like mining or metalworking carried out by some long-lost civilization. In much the same way, cores of ancient ice taken from Antarctica or Greenland are also incredibly valuable. These ice cores trap layers of ash from old volcanoes, tiny particles from the air, and even pollution. Scientists can study these layers and look for artificial chemicals, like man-made industrial gases or synthetic pollutants. If any of these are found in ice layers that are far older than modern civilization, it could suggest that someone long ago had the technology to create such substances. To find such tiny clues, scientists use extremely precise tools. Techniques like mass spectrometry, isotope analysis, and synchrotron radiation allow them to detect the smallest traces of unusual materials. These techniques can even tell the difference between minerals that form naturally and those that might have been shaped or changed by technology. For instance, strange isotopes found in an ice core or sediment layer might reveal that someone, millions of years ago, was building things or processing materials in a way that nature alone would not produce. Because of this, deep-sea sediments and polar ice cores are now seen as some of the most powerful tools for uncovering the mysteries of ancient technology. They help us build a detailed timeline and allow us to match strange findings with specific moments in Earth's past. When combined with modern scientific techniques, these layers might reveal evidence of civilizations that vanished long before humans ever walked the Earth. But to truly understand what we're seeing in these ancient records, we also need to know when things happened. That's where the science of geochronology, dating the age of rocks and minerals, becomes incredibly important. Without accurate dating methods, strange discoveries could be misunderstood or wrongly placed in the timeline of Earth's history. Geochronology is the science that helps us put dates on ancient rocks, ash layers, and mineral changes. One of the most trusted methods is radiometric dating, which looks at how radioactive elements inside rocks slowly break down over time. For example, uranium-lead dating is often used to determine the age of zircon crystals in volcanic ash. These crystals can be over 1 billion years old. When scientists find unusual materials or patterns in the same layers as these crystals, dating can help figure out if those things might be signs of technology from an earlier time. Another technique, known as argon-argon dating, is especially useful for studying volcanic eruptions. It helps place a precise date on the ash layers that might contain buried artifacts or unusual materials. Thermochronology, which measures how long it has been since a rock cooled down, can show when rocks were uplifted or buried, events that might explain how ancient structures came to be hidden or destroyed. Newer methods like isotope geochemistry also let scientists study changes in the environment. By looking at shifts in the ratios of certain isotopes, like those of carbon or oxygen, scientists can detect major changes in climate or atmosphere. If those changes seem to match patterns we see today from industrial activity, they might be a clue that something similar happened long ago. However, using these dating tools correctly takes great care. Not every unusual pattern means a lost civilization existed. Nature can create strange things too. That's why scientists must always check the context in which materials are found, what's around them, what layer they came from, and what other clues are nearby. Even though modern geology has greatly improved our understanding of Earth's incredibly long and complex history, it still has some big challenges, especially when it comes to finding signs of civilizations that might have lived on Earth before humans. These challenges mainly come from how slow and powerful geological processes are, and how they constantly change the surface of our planet. Because of this, discovering any traces of ancient non-human civilizations becomes a very difficult task. One of the biggest problems is time itself. If such ancient civilizations did exist, they might have lived millions or even hundreds of millions of years ago. Over such huge stretches of time, many clues they may have left behind, such as tools, buildings, or even changes in the environment, could have been erased, buried, or hidden by natural forces. The Earth is always changing due to erosion, shifting tectonic plates, volcanic eruptions, and layers of sediment building up. These powerful forces can completely wipe out weak or temporary signs of ancient life. For example, if a civilization used mostly wood, plant fibers, or other materials that break down easily, it's unlikely that much would survive after so many millions of years. In addition to that, the scientific tools we use to study the Earth's past have their limits. Methods like radiometric dating, isotope analysis, and studying layers of rock, known as stratigraphy, are great at helping scientists figure out the age of fossils, rocks, and other materials, but only up to a certain point. These methods become less reliable the farther back in time we go, especially when we're talking about hundreds of thousands or even millions of years. So if there was an early intelligent civilization during one of these distant time periods, we might not be able to detect it very clearly, if at all. Another challenge is that not all evidence is straightforward. Sometimes clues from ancient civilizations could be indirect, like unusual chemical patterns in minerals, strange types of sediment, or odd mixes of isotopes. These might look like natural changes at first glance. It takes a very trained and careful scientist to notice when something might actually be the result of intelligent activity. But often, these subtle clues are overlooked or dismissed because they don't stand out enough. There's also something called preservation bias. This means that certain places on Earth are much better at preserving ancient things than others. Dry caves, deserts, and areas with very stable conditions are good at keeping evidence safe for a long time. but places with water, heavy rain, or lots of volcanic activity tend to destroy or wash away artifacts quickly. So if an ancient civilization lived in one of these harsh environments, there's a good chance we'd never find their remains. Because of all these difficulties, even though our scientific tools are powerful, they still give us only a partial view of Earth's deep past. This opens up a fascinating idea. Could it be possible that traces of an ancient civilization were erased by nature or hidden beneath the surface of the Earth? Or even more dramatically, could the traces have been wiped out by giant cosmic events? This is where things get even more interesting. Scientists and thinkers have long been fascinated by the idea that events from outer space, like massive asteroid strikes, exploding stars, called supernovae, or intense radiation bursts, might have changed the course of life on Earth. These huge events have the power to destroy entire ecosystems, reshape the surface of the planet, and possibly even erase all signs of civilizations that once existed. One of the most famous examples is the asteroid that hit Earth around 66 million years ago. This giant impact caused what scientists call the Cretaceous-Paleogene extinction event, which led to the extinction of the dinosaurs. But it didn't just affect animals. That impact changed the Earth's environment, climate and surface in enormous ways. It left behind a special layer of material filled with the rare metal iridium, as well as shocked quartz and a huge crater. These are things that scientists can still find in rocks today. But if an intelligent civilization had existed before that asteroid hit, the impact might have completely buried their cities and artifacts under thick layers of debris or turned them into different kinds of rock through heat and pressure, making them almost impossible to recognize. Other powerful space events could have had similar effects. For example, a nearby supernova or a gamma-ray burst, huge explosions of energy in the universe, could have blasted Earth with radiation. That radiation might have destroyed the ozone layer, changed the climate for thousands of years, and made it much harder for life to survive. Any technology or structures from a civilization existing at the time might have been broken down by harsh weather, rising oceans, or fast erosion. And these space disasters don't just happen on their own, they can cause other events too. An asteroid strike, for instance, could set off volcanic eruptions, giant earthquakes, or long-term climate changes. These follow-up effects could further destroy or bury signs of civilization. This makes things even harder for scientists and archaeologists who are trying to figure out what Earth was like in its distant past. All of this shows us that cosmic events could play a major role in hiding or erasing the evidence of ancient civilizations. But here's the twist. They also leave their own clues behind. So while these disasters might cover up ancient footprints, they also leave marks in the rocks that scientists can study, like craters, special chemical layers, and changes in the Earth's surface. By learning how to read these marks more carefully, we might one day uncover signs of intelligent life that lived long before us. And that leads us to a new and even more intriguing question. What do fossils tell us about the possible existence of ancient civilizations that were not human at all? Fossils are like time capsules buried in stone, precious records that give us a window into Earth's incredibly ancient past. They help scientists piece together the story of life on our planet, showing how living things have changed and evolved over millions and even billions of years. Normally, fossils are thought to be the remains of once living creatures, plants, animals, or tiny microbes. But sometimes, strange and puzzling fossils are found that don't quite fit this idea. These rare finds raise fascinating questions. Could some of these unusual fossils point to something other than biology? Perhaps the remains of ancient technology, or even long-lost civilizations that existed before humans? One especially curious group of fossil discoveries includes unusual mineral patterns and microscopic structures that are very hard to explain through normal biological processes. In some cases, researchers have found fossilized shapes that look incredibly precise and geometric, symmetrical patterns and complex structures that are rarely seen in nature. For example, some microstructures buried in rock look almost like they were carefully built, with patterns that repeat and shapes that resemble parts of machines more than tissues of living organisms. Some of these even have intricate, repeating tree-like, or fractal, designs, which are not common in known biological fossils. Even more surprising are the tiny bits of metal or carbon found within layers of ancient sediment that resemble man-made objects. Some of these inclusions have surfaces that are smooth and regular, layered like composites, or even look like miniature assemblies of parts. These features are hard to explain with what we know about how fossils form. In fact, if we find fossil-like objects that have very fine grooves, perfect circles, sharp edges, or tiny holes that look like they were made with tools, especially if they're found right next to regular biological fossils, it naturally leads us to wonder, were these things made by someone or something intelligent? Another interesting direction scientists are exploring involves strange chemical and elemental clues locked inside rocks. For example, some fossils contain elements or metal alloys that don't usually form through normal geological processes. Some materials look like they've been heated or altered in ways that suggest they went through some kind of industrial process. These chemical fingerprints might point to artificial origins, especially if they're found together with the geometric or structural anomalies mentioned earlier. Sometimes, researchers even find markings carved or scratched onto fossilized shells or bones, markings that seem too precise and too regular to be caused by nature alone. When these engravings look like symbols, patterns, or artificial designs, they could hint at craftsmanship, tools, or perhaps machines. This possibility opens up an entirely new way of thinking about Earth's history. What if, long before humans ever appeared, some other intelligent beings walked this planet? Of course, most fossils show clear signs of biological life, such as shells, bones, or the shapes of leaves and roots. But every now and then, scientists come across something that stands out, something that seems different, as if it doesn't belong. These unusual fossils may contain hints that intelligent design or technology once existed on Earth in the deep past. One possible clue is the presence of mineral structures that look like manufactured parts. These might include repeating patterns that mimic circuits, layered designs that resemble artificial materials, or even tiny lines and shapes that suggest machines. Some researchers have discovered microfractures that seem to follow exact shapes or directions, as well as metals that look like they were mixed or engineered, rather than naturally formed. In some rare cases, fossils seem to include structures that resemble microelectronic circuits, which is hard to explain using just biology or geology. Another promising area of study focuses on fossils that come from microbial mats, or ancient slime-like layers left behind by colonies of tiny organisms. If these structures are arranged in neat layers, with clear symmetry or other signs of organization, they might point to something more than just natural microbial growth. Some of these fossilized mats even contain strange chemical signals, such as unusual combinations of elements or unnatural isotopic ratios, which might suggest the presence of non-biological materials. This could support the idea that something artificial was at play. But there's a big challenge. How do we tell the difference between a real anomaly and a natural oddity? Sometimes the process of fossilization itself can change the shape or chemistry of a fossil, making it look stranger than it really is. That's why scientists now use powerful tools to study these mysteries. Advanced microscopes, special radiation scanners, and chemical analysis methods allow researchers to zoom in on fossils at the microscopic or even nanoscopic level, revealing details so tiny that they can't be seen with the naked eye. If any features discovered through these methods clearly don't match what nature would normally produce, it could be a strong sign of ancient technology or intelligent activity. All of this leads us to a bigger question. Could these tiny fossil clues, especially the ones too small to see without powerful equipment, actually reveal signs of advanced biological or even technological processes? The study of microfossils, fossils that are smaller than a millionth of a meter, is a fascinating field. These tiny remains can be found in rocks that are thousands, millions, or even billions of years old. Microfossils have helped scientists learn about the earliest forms of life, long before plants and animals appeared. Traditionally, these fossils were thought to represent very simple life forms like bacteria or algae. But recent discoveries suggest that even these early organisms might have had more complex behaviors than we thought. For example, some microfossils appear to have organized shapes, with cells that seem to work together or form networks, like early versions of biofilms or microbial communities. This could mean that even the simplest forms of life were already developing ways to cooperate, share resources, or communicate, traits we usually associate with more advanced life. Chemical studies of these microfossils have also turned up surprising results. By measuring the types of carbon or sulfur isotopes trapped inside them, scientists can sometimes tell what kind of metabolism the ancient microbes used. Some of these isotopic ratios match what we see in modern microbes that live in extreme environments, such as those that perform photosynthesis or survive in high heat or acidity. This suggests that early life may not have been so basic after all. It might have included a range of sophisticated behaviours and adaptations that we're only just beginning to understand. Some researchers even propose that certain microfossils might show signs of ancient technology or artificial influence. For instance, if a fossil contains metal, layered materials, or tiny structures that look like tools or circuits, it could mean that these early microbes were interacting with their environment in ways that resemble engineering or design. While these ideas are still debated, they encourage scientists to look more closely at the tiniest traces of the past. The discovery of ancient life, whether simple microbes or more complex organisms, opens an exciting window into Earth's distant past. It helps scientists understand how life may have begun and how it slowly changed and evolved over billions of years. But these discoveries also bring along many puzzles. Figuring out what these fossils really are and where they came from is not always easy. In fact, sometimes it's like trying to solve a mystery with only half the clues. Some of the oldest traces of life on Earth come from fossils of microscopic organisms, often preserved in rocks as tiny mineral threads or in layered structures called stromatolites. These ancient formations are among the earliest signs of life, and some may be more than 3,500,000,000 years old. That means life may have appeared on our planet not long after Earth itself formed. But because these fossils are so small and simple in shape, scientists often struggle to tell whether they are truly biological remains or just patterns created by natural non-living processes. For example, certain minerals can form shapes that look very much like tiny colonies of microbes, making it difficult to say for sure whether they were once alive. The challenge becomes even more complicated when we look at fossils of more advanced creatures, such as soft-bodied animals or the earliest examples of multicelled life. These fossils may have complex shapes and fine details that suggest life was already quite advanced at an early stage in Earth's history. But interpreting these fossils is tricky. Over time, the way organisms decay and how their remains get preserved in rock can change their appearance. This process, known as taphonomy, can make it hard to tell what the original creature looked like, or even whether it was ever alive in the first place. Sometimes, what looks like a fossil may turn out to be a mineral formation that just happened to take on a lifelike shape. Another important part of this puzzle is the rock layer or stratum in which a fossil is found. Scientists study the layering of sediments to understand the age and origin of fossils, but even this can be misleading. Mineral-rich water can move through rock and leave behind deposits that form patterns similar to those made by living things. These purely geological formations, though formed by natural forces like pressure and chemical reactions, can closely mimic biological shapes. As a result, researchers must be extremely cautious when they come across fossil-like features. They may not always be what they seem. To solve these mysteries, scientists rely on very precise and careful methods. They use tools like high-powered microscopes, chemical tests, and isotopic analysis, which looks at the types of atoms in a sample, to search for biosignatures, clues that a sample came from a living organism. These clues might include certain types of molecules or unusual ratios of atoms that are hard to produce without biological processes. Still, even with all this technology, it's possible to get false positives, samples that look biological but actually aren't. That's why experts from many different scientific fields must work together to investigate these ancient traces of life. Their job is not just to examine the fossils, but also to understand the bigger picture, where they were found, how they were formed, and what they might mean. But what if some of these fossils aren't just signs of life? What if they're signs of something much more advanced? What if, hidden deep within the layers of rock, there are clues pointing to the existence of civilizations that lived long before humans ever walked the Earth? This fascinating idea brings us to an even more difficult challenge. Some scientists and thinkers have wondered whether certain unusual structures in the fossil record could actually be ancient tools, machines, or even parts of advanced technologies. But trying to tell the difference between natural mineral formations and artificial human-made objects from deep time is extremely difficult. Many naturally occurring processes, like crystal growth, pressure, or chemical changes, can create shapes that look surprisingly like artifacts. For example, some mineral concretions, rounded stone formations, or fossilized microbial films can look very much like carved surfaces, gears, or mechanical parts. One of the biggest problems is that nature itself can be very good at creating patterns and shapes that look designed. Crystals, for example, can grow in perfect geometric shapes, with straight lines and sharp angles. These shapes can easily be mistaken for tool marks or machine parts. Even microbial colonies, when fossilized, can form repeating textures that look like they were made by intelligent hands. That's why scientists must use many different types of analysis, such as ultra-detailed imaging, chemical fingerprinting, and microscopic inspection, to figure out what they are really looking at. There's another major problem too: time. If a civilization existed hundreds of millions, or even billions of years ago, then whatever it left behind would likely be deeply buried, eroded, or changed beyond recognition. Over such long periods, even strong materials like metal or stone can be broken down, crushed, or transformed by heat and pressure. Without clear signs, like tool marks, carvings, or a grouping of objects that obviously don't belong, it's almost impossible to tell whether a strange structure in the rock is natural or not. Adding to the confusion, Earth still holds many geological secrets. Some rock formations and structures that we find today don't fit into current scientific explanations. These unexplained formations could simply be rare natural events, but they might also be something more. That's why scientists are encouraged to be both cautious and open-minded, using every tool available to investigate these mysteries. They look closely at the shapes, materials, and surroundings of each discovery, asking whether it truly came from nature or from a forgotten hand. This line of thinking leads to a captivating question. Could there be fossilized remains of ancient machines, tools, or technologies buried within the Earth? Although this idea is highly controversial, it's not entirely out of the question. Some fossil-like objects found in sedimentary rocks have sparked debate because they show patterns that are symmetrical, precise, and complex, traits we normally associate with tools or machines. In some cases, scientists have even found metallic-looking inclusions, tiny pieces inside fossils, that under a microscope seem to have patterns resembling gear teeth, hinges, or other mechanical components. If any of these features were proven to be real artifacts, it would rewrite everything we know about Earth's history and humanity's place in it. But before jumping to conclusions, scientists must consider simpler explanations. Many of these shapes can still be explained by natural processes, such as the way minerals grow and settle over time. Some silicate crystals, for instance, naturally form in shapes that can look like screws, bolts, or parts of a mechanism. And over millions of years, even real metal would likely corrode or be replaced by minerals, making it even harder to identify. Equally important is context. A single strange object found in isolation doesn't prove anything. But if similar objects were found at multiple sites, with signs of advanced activity like worked surfaces, artificial alignment, or unnatural materials, the case would become much stronger. So far, however, no such discovery has been confirmed beyond doubt, and that brings us to the heart of the mystery. Could the fossil record, the grand archive of life on Earth, contain hints not just of plants and animals, but of civilizations that lived and vanished long before our own? The fossil record is one of the most important tools scientists use to study the ancient history of Earth. It gives us a way to look far back in time, millions and even billions of years, to understand how life has changed and evolved. But when scientists try to use the fossil record to search for signs of civilizations that may have existed long before humans, they run into many difficulties. While some clues might support the idea of such civilizations, many others raise doubts or are too unclear to prove anything for sure. Fossils usually form when hard parts of living things, like bones, shells, or teeth, are buried and preserved over time. But this process is very picky. It does not preserve everything. Soft materials such as wood, fabric, or even the remains of technology like wires or tools rarely survive long enough to become fossils. That means if an ancient civilization left behind things made of soft materials or delicate machinery, those items would almost never be found in fossil form today. This makes it much harder for scientists to detect signs of complex, possibly advanced societies that may have lived before humans. Even when strange findings do show up, like odd-shaped structures in rocks or layers of minerals that don't quite fit the usual patterns, they are often explained away as natural, not artificial. Many scientists are cautious and tend to dismiss these discoveries if they resemble things that nature could have created on its own. Some unusual mineral patterns or strange arrangements of sediments might actually be clues, but they are often too subtle for our current tools to recognize, and without clear, solid artifacts like tools, buildings, or inscriptions, it is very difficult to prove that these are the results of intelligent activity. On the other hand, the fossil record does offer a few curious hints that could support the idea of pre-human civilizations. For instance, the sudden appearance of certain kinds of minerals or the presence of unexpected tiny fossils, called microfossils, in certain rock layers might point to large changes in the environment. These changes could have been caused by advanced life forms doing things like mining, building cities, or using energy on a large scale. However, these signals are vague. It's hard to tell if they came from natural processes, like volcanoes or climate changes, or from intelligent beings doing something purposeful. In general, while the fossil record gives us amazing snapshots of life's long journey on Earth, it does not clearly support the idea of ancient advanced civilizations before humans. There are no unmistakable, well-preserved signs of such societies, and the lack of strong evidence shows how important it is to improve the ways we search. If we want to find subtle or hidden signs of ancient intelligence, we need better tools and new ideas. This leads us to wonder, what new methods could help us search deeper into the past and possibly uncover signs of civilizations we've never known? Thankfully, scientists are now developing exciting new technologies that may help us find what has long been hidden. Traditional fossil hunting methods often rely on what can be seen on the surface or dug up in shallow layers, but modern techniques are going far beyond that. One powerful method is called ground-penetrating radar, or GPR. When combined with special three-dimensional imaging, it lets scientists see what's underground without digging anything up. These tools can detect buried structures or shapes that might be old buildings or roads, even if they're covered by many layers of earth and rock. When artificial intelligence is added to the process, computers can quickly scan massive amounts of data and point out anything that looks unnatural or possibly man-made, saving researchers lots of time and effort. Another breakthrough is called spectral imaging. This technology looks at objects using many different kinds of light, not just what we see with our eyes, but also infrared and ultraviolet light. This helps scientists detect chemicals or materials that may have been used by intelligent beings. For example, certain paints, metals, or synthetic materials leave behind clues in the way they reflect light. Spectral imaging can be done from planes, drones, or satellites, allowing researchers to scan entire landscapes that are too remote or dangerous to visit in person. Scientists are also using advanced forms of isotope analysis. One such method, known as clumped isotope thermometry, can measure the temperature and chemical conditions that existed when certain rocks or fossils formed. If these temperatures don't match what we'd expect from natural processes, it could suggest something unusual happened, possibly related to intelligent activity, like machines, industry, or artificial heating. Another helpful tool is micro-CT scanning, which creates extremely detailed, three-dimensional pictures of very small objects trapped inside rocks. This lets scientists see fine details, like tiny tool marks or layers that look like they were carefully built, without destroying the sample. It can help identify possible signs of craftsmanship or technology that are too small or fragile to examine by hand. All these high-tech tools are opening up new possibilities for finding out what really happened on Earth in the very distant past. Sometimes, archaeologists discover strange objects or structures that don't seem to fit with what we think we know about human history. These unusual findings, often called archaeological anomalies, raise big questions. They challenge our usual understanding of the past and make us wonder, could another, possibly non-human civilization have existed on Earth long before us? These strange clues come in many forms. Some are ancient tools or artifacts that seem too advanced for their time. Others are massive stone structures that show an incredible level of skill, far beyond what early humans were believed to be capable of. When we take a closer look, some of these discoveries seem to have been made using knowledge or technology that shouldn't have existed yet, at least not according to our current timeline of history. One of the most fascinating mysteries is the existence of ancient structures that appear to be built with astonishing precision. In many places around the world, we find huge stone buildings and monuments that are perfectly aligned with the stars or the sun, something that would have required an impressive understanding of astronomy and engineering. But here's the twist. These structures were built thousands of years before modern civilizations were thought to have this kind of knowledge. Take, for example, the massive stone monuments found in places like Egypt, South America, or Southeast Asia. Some of these are not only massive in size, but also built with geometric precision that still amazes engineers today. How did ancient people, without modern machines or computers, manage to carve, move, and align such gigantic stone so perfectly? Could they have had help, or could they have inherited this knowledge from a civilization that came long before them? The mystery deepens when we find metal objects or materials that seem completely out of place. In some ancient layers of Earth, layers that are tens of thousands or even millions of years old, archaeologists have unearthed metallic tools, advanced alloys, and even synthetic materials that, according to our textbooks, shouldn't have existed back then. In some cases, these materials have unusual isotopic signatures or contain traces of substances that we don't yet fully understand. Could these be the leftovers of lost knowledge, or even signs of technological processes that go far beyond anything early humans were capable of? If so, where did that knowledge come from? Then there are the even stranger discoveries. Carved stones marked with symbols that don't match any known language or culture, and tools or objects with no clear purpose or origin. These items often seem to come from nowhere, showing a level of craftsmanship or intent that doesn't align with any ancient culture we know. Some objects appear to have been machined with great precision, or bear markings that look more like those made by industrial tools than by hand chisels. These mysteries suggest the presence of an intelligence, maybe even a civilization, that operated with a level of knowledge far ahead of its time. Other strange findings involve structures built in places that seem almost impossible to reach or work in. For example, there are perfectly straight roads stretching over rough mountains and deep valleys, and underground chambers carved into solid rock with no clear entry point or explanation for how they were made. Some of these underground structures are so vast and complex that they baffle modern engineers. Could they have been made by an advanced species, perhaps one that wasn't human, using tools and technologies that we no longer possess or understand? All of these discoveries, when looked at together, are like pieces of a puzzle. They don't fit neatly into the story we've been told about human history, that we evolved slowly over time, building up our knowledge little by little. Instead, they hint at the possibility that our past may be far more mysterious, layered, and complex than we ever imagined. What if long before the dawn of recorded history, a technologically advanced civilization, maybe even non-human, walked this earth? What if we are only now beginning to uncover their fingerprints, hidden deep beneath layers of time? Mainstream archaeology teaches that modern human civilization began around 10,000 years ago, slowly growing from simple farming communities into complex societies. But the strange and out-of-place artifacts mentioned above cast serious doubt on that tidy timeline. Some of these discoveries, such as tools, carvings, or metals found in ancient rock layers, seem far older than they should be. Others show a level of skill and precision that early humans supposedly didn't have. These clues suggest that something is missing from our current understanding, possibly even an entire chapter of history that has been forgotten. Many of the strangest objects can't be properly dated. Others seem to have been made using advanced machining or metallurgy techniques that shouldn't have been available at the time. Could this mean that some ancient cultures were far more advanced than we think? Or could these be remnants of a civilization that existed long before humans, perhaps even one that we have no record of at all? Some scientists have even proposed bold ideas like the Silurian hypothesis, which asks, what if a smart industrial civilization existed on Earth millions of years before humans and vanished without a trace? If this is true, Some of the strange items we've found might be their leftovers, left behind like forgotten tools in an ancient workshop. These oddities don't just challenge our ideas of the past, they also expose potential weaknesses in our methods. What if the tools we use to dig up history are missing some of the most important clues? What if we've already found signs of the lost civilizations but brushed them off because they didn't fit the story we expected? If we open our minds to new possibilities, we might begin to see that the past isn't a straight line. It's more like a maze, filled with twists, turns, and secrets still waiting to be uncovered. Some of the world's most famous ancient monuments might hold hidden meanings if we look at them through the lens of this idea. Structures like the megalithic stone circles in Europe, the giant stone heads of Easter Island, and the pyramids of Egypt have long puzzled experts and inspired wild theories. Take Göbekli Tepe, for example, a site in modern-day Turkey believed to be the oldest known megalithic structure in the world, built more than 11,000 years ago. Its towering stone pillars are decorated with carved animals and strange symbols, but what's truly shocking is that it seems to have appeared suddenly in the archaeological record, with no earlier examples to explain its origin. Did this knowledge come from an older civilization that we no longer remember? Or consider the Nazca lines in Peru, giant drawings carved into the earth, only visible from the sky. How did ancient people make such massive figures without being able to see them from above? Could this hint at knowledge of aerial viewing, possibly handed down from an older and more advanced society? Even the Egyptian pyramids and the temples of Malta are full of mysteries. Their perfect alignments with stars, their strange internal acoustics, and the size of the stones used suggest a kind of engineering that may have been far ahead of its time. Some of the world's most mysterious and awe-inspiring ancient structures might offer important clues that challenge what we think we know about history. These giant buildings, often called megastructures, are not like the usual ruins we find from ancient times. They are enormous, incredibly precise, and sometimes seem to have been built with skills or knowledge that don't match the time periods we associate them with. For example, at several ancient sites around the world, massive stone blocks have been carefully fitted together without using any kind of cement or mortar. These stones are not only gigantic, but also perfectly aligned, sometimes with the stars or the sun, showing a deep understanding of mathematics and astronomy. Stone circles, huge terraces, and water-carrying systems known as aqueducts seem to show that the people who built them had an advanced grasp of engineering, possibly beyond what we thought was possible for ancient civilizations. What makes these ancient structures even more fascinating is the level of planning, skill, and possibly even machines involved in building them. In some places, enormous stones were carved with incredible precision and moved across long distances, something that would be very hard to do even today without powerful tools. Some researchers believe that the builders may have used advanced materials, like early types of concrete or artificial stone, which seem too modern for the times they came from. These ideas suggest that knowledge or technologies might have existed in the past, but were forgotten over time. In some cases, the way these buildings were made is so strange that it raises even more questions. Multiple layers of different materials, complex shapes, or buildings that don't seem to serve any clear purpose might mean they had symbolic, religious, or astronomical meanings. This suggests that the people behind these structures were not only skilled builders, but also had a rich and complicated culture. All of this leads to a bigger mystery. Could there have been earlier civilizations, possibly even global ones, that were far more advanced than we thought? And if so, what happened to them? Many of these ancient wonders are located in places that are now underground or underwater. These hidden places might hold the answers to questions about civilizations that came long before our own, and then vanished without a trace. That's where the Silurian hypothesis comes in. This is the idea that an advanced civilization might have existed on Earth millions of years ago, long before modern humans. If such a civilization did exist, its remains might now be buried beneath layers of Earth or submerged deep under the ocean. Underground and underwater archaeological sites are especially important because they can protect ancient ruins from erosion, looting, and other types of damage. These sites might contain old tools, buildings, or even remains of cities that have been sealed off for thousands or even millions of years. For instance, underground tunnels and buried cities could hold clues about lost technologies, while sunken settlements beneath the sea might show signs of intelligent life that lived during a forgotten chapter of Earth's history. Some researchers believe that entire cities may have been swallowed up by rising sea levels or major disasters, leaving behind only ruins hidden below the waves. Discoveries like these could totally change how we see human history, and possibly reveal that intelligent beings lived on Earth long before us. But finding these lost sites isn't easy. Earth is a huge place, and natural processes like earthquakes, landslides, and the slow movement of soil can cover up or destroy evidence. Traditional digging methods can't reach many of these places. That's why scientists now rely on powerful modern tools to help them explore. Two of the most important technologies being used today are ground-penetrating radar, GPR, and LiDAR, short for light detection and ranging. Ground-penetrating radar works by sending radio waves into the ground. When those waves hit something underground, like a buried wall, a hidden tunnel, or even an ancient object, they bounce back. The radar picks up the echoes and creates images of what's below the surface. This helps archaeologists know where to dig and what to look for, without having to dig up everything blindly. LiDAR is another amazing tool. It uses laser beams, usually from a drone or airplane, to scan the ground from above. These lasers can see through thick forests and other obstacles that normally hide ancient ruins. By measuring how long it takes for the laser light to bounce back, LiDAR creates detailed 3D maps that show even small changes in the landscape, like old roads, building outlines, or hidden pyramids. Some lost cities have already been found using this technology in places like Central America and Southeast Asia. These high-tech tools allow scientists to explore huge areas quickly, safely, and in great detail, something that would take years to do by hand. They also help researchers compare sites in different countries, uncovering patterns and similarities that might point to a shared global culture that existed long ago. However, even though GPR and LiDAR are incredibly powerful, they come with their own challenges. The amount of data they produce is massive, and interpreting it takes skill and experience. Sometimes it's hard to tell the difference between man-made objects and natural formations, and even when something strange is discovered, scientists still need to prove how old it is, who made it, and what it was used for. That brings us to the next big question. Once we find something unusual, how do we know it's real, and how do we figure out how old it is? These are the puzzles that researchers must solve if we are ever to uncover the true story of Earth's ancient past. Could it be that long before modern humans walked the Earth, another intelligent civilization built wonders that now lie hidden, waiting to be rediscovered, trying to prove whether strange-looking artifacts are real, and figuring out exactly how old they are is one of the hardest tasks researchers face. This is mainly because today's scientific tools, though powerful, have their limits, and the objects themselves are often mysterious and difficult to study. One major problem is telling the difference between truly ancient items made by intelligent beings and modern copies or naturally formed objects that just look like they were crafted by someone. Sometimes, even rocks shaped by wind or water over thousands or millions of years can resemble man-made tools or structures. Scientists use a variety of methods to date artifacts and determine their origins. Techniques like radiocarbon dating, thermoluminescence, and stratigraphic analysis can offer clues about how old something is or what layer of Earth it came from. But none of these methods are perfect. They rely on certain assumptions, like the idea that specific chemical elements or layers in the soil have remained unchanged over time. Unfortunately, environmental conditions, contamination, or movements in the ground can disturb these layers or chemical traces, making the results unclear or even misleading. Things get even more complicated when the artifact in question doesn't fit into what we currently understand about ancient history. Objects with strange shapes, unusual materials, or unknown construction methods are often met with deep skepticism. Some scientists might quickly dismiss them as natural rocks or modern fakes. However, unless these conclusions are supported by strong evidence, such as dating from multiple techniques, consistent placement in undisturbed soil layers, or nearby related artifacts, the verdict remains uncertain. The task becomes even more difficult when the object is broken, worn down, or has been affected by natural forces like wind, water, or volcanic activity over tens of thousands or even millions of years. Adding to the challenge is the fact that nature itself can sometimes produce shapes that closely resemble crafted tools or ornaments. Certain rock formations, mineral crystals, or even hardened lava flows can, at a glance, look like carved stones or pieces of machinery. These misleading shapes can easily be mistaken for human-made artifacts. To tell the difference, scientists have to study the object carefully, using knowledge from geology, the study of Earth's layers and rocks, mineralogy, the study of minerals, and how natural formations develop over time. Experts often examine these questionable objects under powerful microscopes, perform chemical tests to identify what they're made of, and use 3D scanning to search for signs of carving or shaping. Real artifacts tend to show signs of deliberate work, like straight cuts, repeated patterns, smooth surfaces, or marks left by tools. In contrast, natural objects usually have uneven, jagged, or chaotic patterns caused by natural forces like erosion, crystal growth, or underground pressure. One of the most important parts of figuring out if an object is real is its context, where it was found and what was found around it. If the object was buried in the same soil layer as other ancient items like stone tools, pottery, or bones, then it's more likely to be real. But if it was found all alone or in a disturbed area, then scientists have to be much more cautious. It's also important to study the local geology. Knowing the history of nearby volcanoes, rivers, or rock formations helps researchers decide whether something was likely made by nature or by intelligent hands. High-tech tools are becoming more helpful in this detective work. Spectroscopy, for instance, can reveal what kind of materials the object is made from, and whether they match those found in known human tools. 3D scanning and even electron microscopes can uncover tiny details, like scratch marks from tools or grooves from shaping, that the human eye can't see. When scientists combine all these methods with the knowledge of archaeologists, chemists, and geologists, they can build a much clearer picture of what the object truly is. Climate change and shifts in the environment have played a powerful role in shaping the story of human history, and perhaps even the hidden stories of civilizations that came before us. These natural forces act like both protectors and destroyers. Sometimes they help preserve traces of the past. Other times they wipe the evidence away completely, leaving behind only whispers buried deep in the earth. On the one hand, nature can be an incredible guardian of history. Certain conditions, like fast burial under mud or sand during floods, the cold and airless environment of peat bogs or deep caves, or being sealed in ice or covered by volcanic ash, can protect ancient objects and even human remains for thousands of years. A famous example of this is Ötzi the Iceman, who lived over 5,000 years ago. His body was found frozen in the Alps, perfectly preserved by the cold. In other places, entire towns have been covered by ash from volcanic eruptions, freezing them in time and giving us rare, detailed snapshots of life in the distant past. But nature can also act as a great eraser. Enormous changes like ice ages have dramatically reshaped the Earth. Thick ice sheets can grind down landscapes, crush artifacts, and erase whole coastal settlements as sea levels rise and fall. Glaciers can scoop up or bury ancient remains and move them far from where they were originally left. Volcanic eruptions, while sometimes preserving things, can also destroy everything in their path, burning, burying, or scattering what remains of past civilizations. The oceans have their role too. When sea levels rise, entire coastal cities can be swallowed, hiding all evidence underwater. When the sea retreats, it can reveal sunken lands that were once thriving settlements. These powerful natural events are like a double-edged sword. They can either protect ancient secrets for thousands, or even millions of years, or they can erase them completely. That's why understanding how the Earth's environment changes is so important to archaeologists and geologists. These forces shape what we can find, what survives, and how we interpret the story of civilizations long gone. This constant push and pull between preservation and destruction sets the stage for deeper questions. How have past ice ages, volcanic eruptions, and oceanic shifts shaped our ability to discover forgotten civilizations? Could there be entire chapters of Earth's history missing simply because nature swept them away? Let's look more closely at how some of these forces work. During ice ages, which have happened many times over millions of years, massive sheets of ice stretch across continents. These glaciers can act like natural freezers, preserving objects and remains in the frozen ground. But as they move, these glaciers also act like bulldozers, flattening the land, crushing artifacts, and dragging debris over great distances. When the ice finally melts, it can wash away what little is left, or leave evidence jumbled and scattered. In some areas, the weight of the ice pushes the ground down and distorts the natural layering of soil and rock, making it much harder for scientists to figure out the age and origin of what they find. In places that were not covered by ice, sea levels during ice ages dropped dramatically. This revealed land bridges, like the one that once connected Asia to North America across what is now the Bering Strait. These exposed lands made it possible for people, and possibly earlier civilizations, to migrate across continents. But when the Ice Age ended and sea levels rose again, many of those areas were drowned, possibly taking entire settlements with them. Volcanoes add another layer of mystery. When they erupt, they can quickly bury entire towns and forests in volcanic ash or lava. The ash, called tephra, can cover everything in a thick blanket, freezing a moment in time. This can sometimes preserve things with incredible detail, almost like a natural time capsule. But future eruptions, earthquakes, or erosion can later disturb or even destroy these delicate layers, scattering the evidence. Volcanic landscapes themselves constantly shift, which complicates scientists' efforts to analyze what lies beneath. The oceans also play a massive role in what we find and what we lose. Over time, sea levels have risen and fallen by hundreds of feet. When the sea rises, it swallows up coastlines and floods cities, hiding them under layers of silt and coral. When the sea recedes, it can reveal lost lands, like ancient river valleys or shorelines that once hosted thriving communities. The movement of Earth's crust, through a process called tectonic activity, can lift entire regions out of the sea or cause them to sink, messing with the layers of sediment that archaeologists depend on to date what they find. Altogether, these forces create a constantly changing picture of Earth's surface. Some areas may protect ancient clues for tens of thousands of years, while others may bury or destroy them without a trace. This makes the job of finding civilizations that existed before humans, or alongside early humans, a huge challenge. To solve these ancient mysteries, scientists must read Earth's layered history like a detective, sifting through a book with missing pages. Some scientists and thinkers have asked, what if natural disasters didn't just shape history, but completely erased parts of it? Could civilizations that existed long before us have been destroyed so suddenly and completely that hardly any trace remains? We know that environmental disasters have caused major collapses in human societies, but for civilizations that may have existed before us, or early in human history, these events could have had even more dramatic effects. Take, for example, the Younger Dryas, a sudden period of intense global cooling that started around 12,900 years ago. This dramatic shift in climate may have devastated early farming communities and forced entire groups to abandon their homes. Even earlier, about 74,000 years ago, the Toba supervolcano erupted in what is now Indonesia. That eruption was one of the largest in Earth's history and may have triggered a global volcanic winter. Some scientists believe it caused a massive drop in human population, a bottleneck that could have affected both human evolution and the survival of other possible civilizations. Asteroid impacts are another terrifying force. The most famous one happened around 66 million years ago, when a huge asteroid hit Earth near the Yucatan Peninsula. This event, known as the Chicxulub impact, is believed to have wiped out the dinosaurs. If an impact like that happened during the time of a pre-human civilization, it could have ended it almost instantly, crushing cities, destroying food sources, and plunging the world into chaos. But not all disasters wipe everything out at once. Some might weaken a civilization gradually, setting off a chain reaction of problems. A drought could lead to failed crops, which might cause conflict, war, or migration. Over time, the society might fall apart, not with a bang, but with a slow unravelling. Two very basic natural processes, sedimentation and erosion, also shape what survives from the ancient world. Sedimentation is when layers of sand, mud, and organic materials slowly build up over time. In quiet places like lake bottoms or calm river valleys, These layers can gently cover and protect artifacts like tools, bones, or even entire structures. In such calm and stable environments, things can stay preserved for tens of thousands of years. Erosion, though often seen as destructive, plays a double role in the world of archaeology. On one hand, it wears away soil and rock over time, which can damage or destroy ancient sites. But on the other hand, it can also be a powerful tool of discovery. As erosion slowly removes layers of earth, it sometimes uncovers objects and structures that had been hidden underground for thousands of years. What was once buried and forgotten can suddenly come to light, giving us exciting glimpses into the distant past. Places like coastal cliffs, riverbanks, and steep mountain slopes are especially important in this process. These natural landscapes often act like nature's own digging tools. As rain, wind, and water do their work over centuries, they strip away the surface and reveal traces of ancient human life, tools, pottery, bones, and even forgotten dwellings. In this way, erosion doesn't just destroy history, it also helps us find it. But erosion doesn't work alone. It constantly interacts with another powerful natural force, sedimentation, the slow build-up of materials like mud, sand, and minerals that get deposited over time. These layers can cover and protect ancient remains, or sometimes change the environment around them. When minerals mix with the buried materials, they can help preserve them by turning them into stone, a process called mineralization. However, not all chemical reactions are helpful. In some cases, the wrong soil conditions can speed up decay. For example, soil that's very acidic can break down wood, bone, and other organic materials much faster. In contrast, soil that's more neutral or slightly alkaline can keep these remains in good condition for thousands of years. Understanding how erosion and sedimentation work is incredibly important for archaeologists. These processes don't just influence whether artifacts survive, they also affect where those artifacts end up and how easy they are to find. When archaeologists learn to read the signs left behind by erosion and sedimentation, such as unusual soil layers, patterns in the landscape, or exposed artifacts, they can better decide where to dig and how to interpret what they find. But there's another important factor that can hide or reveal traces of ancient civilizations: natural resource deposits. These include things like coal seams, underground water, aquifers, and mineral-rich veins of rock. These deposits can act like both guardians and gatekeepers of history. Sometimes they hide human activity deep underground, and other times they bring it to the surface. For instance, when ancient people mined for minerals or used natural resources, they often left behind clues. These clues might be disturbed rock layers, strange shapes in the ground, or even leftover materials from smelting or tool making. Today, scientists can detect these subtle signs using advanced tools like geochemical analysis, which helps them spot changes in mineral content caused by human activity. In some cases, these resource deposits have actually protected ancient items for thousands of years. Imagine an old mine or a peat bog that preserved wood, cloth, or even human remains so well that they still look nearly untouched today, like nature's time capsules. However, these same deposits can also bury or distort archaeological layers over time, making it harder to tell whether a structure or formation is natural or human-made. Interestingly, areas rich in natural resources were often magnets for early human settlements. People were drawn to these places for their useful materials, like metal ores or fresh water. But mining and other resource-gathering activities often disturbed or destroyed the very evidence archaeologists now search for. Artifacts might be pushed deeper into the ground or broken apart. Still, in some special environments like peat bogs or salty mineral-rich lakes, even fragile materials like fabric or rope can survive for ages. All of this shows why it's so important for experts in different fields, from geology to chemistry to archaeology, to work together. Only by combining their knowledge can they fully understand how natural deposits affect the discovery of ancient sites. Recognizing the role of geology helps researchers figure out where to dig and how to explain what they find, and sometimes it even helps them uncover parts of our past that would otherwise stay hidden. To take this search even further, scientists now turn to a powerful modern tool: climate models. These models help researchers predict where evidence of lost civilizations might be hiding, by showing how Earth's climate has changed over tens of thousands of years. By simulating ancient weather patterns like rainfall, temperature and wind, these models can identify areas that once supported human life but are now covered by deserts, forests or oceans. For example, a region that is dry and lifeless today might once have been a green and fertile valley with rivers, crops and villages. Using paleoclimate data, which includes ancient pollen, ice cores and sediment records, scientists can recreate what the world looked like in different periods. This helps archaeologists focus their efforts on places where ancient people most likely lived, even if those places are now hidden under sand, soil or snow. One especially helpful way climate models are used is in combination with satellite images and ground-penetrating radar. These technologies can detect signs of human-made structures, like ancient roads, canals, or cities buried beneath the surface. When combined with climate models, they offer a clearer picture of where and when these structures were built and why people may have left them behind. These models are not static. They improve over time, using new information from biology, geology and climatology to paint ever more accurate pictures of the past. With these tools, researchers can even identify short-lived climate windows, periods when the environment was just right for human civilization to grow and thrive. Knowing when and where these windows opened up helps archaeologists search smarter, not harder. But the story doesn't end with the past. In fact, future climate change could open up entirely new possibilities and pose serious new risks for archaeology. As global temperatures continue to rise, ice sheets are melting, seas are rising, and weather patterns are changing across the globe. These environmental changes are already reshaping the Earth's surface, sometimes exposing long-hidden sites, and other times damaging fragile remains. For instance, when glaciers melt in places like the Arctic or the Alps, they may reveal astonishingly well-preserved ancient settlements, tools, clothing, and even mummies that were frozen in time. Yet, once these remains are exposed to air and sunlight, they can start to decay rapidly. In other areas, stronger storms and heavier rains may wash away or bury ancient layers of civilization, while new patterns of drought and heat may dry out regions that were once rich in vegetation and water. These changes could lead to better preservation in some dry places, but make exploration harder in others. In places like deserts or frozen tundra, once seen as poor candidates for archaeological study, shifting climate conditions may suddenly make these areas more promising. However, they also come with new complications like salty soil or melting permafrost, both of which can harm ancient artifacts and make excavation more difficult. That's why archaeologists today are racing against time. They know that climate change is altering the Earth in unpredictable ways, and many fragile pieces of human history might soon be lost forever. That's also why it's more important than ever to combine the power of climate science with archaeology, using every available tool to locate, study, and preserve the past before it disappears. Studying how Earth's environment has changed in the past gives us deep and powerful lessons about how human civilizations have survived, or sometimes failed, through the centuries. Many ancient societies such as the Maya in Central America and the people of ancient Mesopotamia in what is now Iraq had to deal with major challenges like changing weather patterns, running out of natural resources, and powerful natural disasters. These struggles often led to serious problems for those societies, sometimes even to their collapse or transformation. These historical stories remind us of a powerful truth. No civilization, no matter how advanced or complex, is completely safe from the forces of nature. One of the most important lessons we learn from the past is the value of being able to adapt. Civilizations that were able to survive tough environmental changes usually found smart ways to adjust. They changed how they farmed, managed their water and forests more carefully, or even reorganized their social systems to better handle the new challenges. On the other hand, societies that ignored the warning signs, like long droughts or damaged soil, often could not survive. A clear example is the fall of the classic Maya civilization, which seems to be linked to major shifts in the climate and the destruction of forests. This shows how environmental stress, when combined with poor responses, can push a society toward disaster. Another key lesson is that long-term planning and taking care of the environment are absolutely essential. Many ancient civilizations did not have the ability, or sometimes the wisdom, to plan for the future. They used up their resources too quickly, and when trouble came, they were unprepared. This led to social breakdowns and even the disappearance of entire cultures. Today, we see similar problems happening again. Climate change, the overuse of fossil fuels, deforestation and pollution are putting modern societies at serious risk. By studying how earlier civilizations collapsed, we are reminded just how important it is to build a future based on sustainability and smart preparation. Interestingly, not all environmental crises led to doom. In many cases, hard times pushed people to become more creative. When faced with droughts, floods, or food shortages, ancient people often came up with new tools, better farming methods, or even new religious beliefs to make sense of their world and survive. These moments of change show the amazing ability of humans to find hope and progress, even when things seem bleak. In the end, looking at how ancient civilizations dealt with environmental changes teaches us that the survival of any society depends on its ability to adapt, to think ahead, and to live within the limits of nature. This is more than just a lesson from history. It is a warning and a guide for our own time. If we truly want modern civilization to last, we must take care of our planet, think for the long term, and be ready to change when needed. As we think about all this, a fascinating question comes to mind. What if ancient civilizations also existed long ago and disappeared just like the Maya or Mesopotamians? And how does this connect with the ongoing search for intelligent life beyond Earth, the work of SETI, the search for extraterrestrial intelligence? Could the rise and fall of ancient human, or even non-human civilizations help us understand what might be happening on other planets? Trying to find the remains of machines or infrastructure built by an ancient civilization isn't as simple as digging in the dirt and hoping to find a gear or a metal pipe. Over thousands upon thousands of years, most surface artifacts are either buried deep underground, destroyed by erosion, or broken down by time. However, a very clever and careful scientist can look for something much harder to erase. Strange patterns hidden in the Earth's electromagnetic fields, gravity, and even in the way sound waves travel through rock. These hidden clues, though invisible to the naked eye, may serve as signs left behind by a long-lost technological world. One of the most exciting types of evidence is called an electromagnetic anomaly. This refers to strange behaviour in the Earth's natural electric or magnetic fields. If an ancient civilization once built machines, power grids, or communication systems on a large scale, those activities would have left behind unnatural electromagnetic fingerprints. For example, ancient underground wires or machinery might change how electricity moves through the soil or create weird magnetic spots that don't match the natural rocks around them. Today, scientists use tools like magnetometers and electromagnetic induction equipment to scan the Earth's surface. These instruments help them spot strange electrical or magnetic patterns. If these anomalies are well organised and don't look like what we'd expect from nature, they might point to something artificial, like a buried power system or forgotten energy device. Gravity is another tool in the modern explorer's toolbox. Everything with mass pulls on everything else, even just a little. So if there's something unusually heavy hidden underground, like a giant machine, a buried chamber, or a dense material unlike anything else around it, that spot will create a tiny but detectable shift in gravity. Using sensitive gravimetric instruments, researchers can map out these shifts. If they find dense spots underground that don't match the natural geology of the area, they might be looking at the remains of an ancient energy facility or a once functioning technological complex. Sometimes, these gravitational changes can even reveal signs of recent movement, hinting that whatever is underground might not be entirely dead and buried. Sound waves moving through the Earth can also reveal hidden secrets. When researchers send seismic waves into the ground, usually by creating small vibrations and recording how the waves bounce back, they can detect strange shapes and materials hidden deep below. If the waves bounce off of tunnels, chambers, or man-made structures, the patterns they create will look different from waves that hit only natural rock. For example, stone buildings or metal machines buried underground can reflect seismic waves in unique ways. This allows scientists to create pictures of what's down there, even if it's hundreds of feet below the surface. These hidden reflections may show us where ancient engineers once built foundations, walls, or complex energy systems. The real magic happens when electromagnetic, gravitational, and seismic clues all line up. When strange magnetic fields appear near gravity anomalies and odd seismic reflections in the same area, it strongly suggests that something unusual, possibly even artificial, is buried there. These overlapping clues could be pointing to the remains of an ancient power system or technology we no longer understand. It raises a powerful question. What kind of energy sources might such a civilization have used? If ancient civilizations did use energy systems, they might not look like anything we know today. Instead of steel wires and power plants, they may have tapped into the natural power of the Earth, using materials and methods now lost to history. For example, if they use geothermal energy, we might find signs of heat that doesn't match the natural flow underground. These hotspots could suggest artificial heating or ancient drilling. Strange patterns in mineral layers might show that the land was once chemically altered by heat or strange reactions. Another clue could come from the rocks themselves. If a rock has odd isotope ratios or contains rare metals, it might mean it was exposed to powerful radiation or used in energy storage. Some old stone sites that are aligned perfectly with the stars or Earth's magnetic field may not be ceremonial as we once thought. They could have been part of large energy systems collecting power from the sun or Earth itself. Even more amazing would be the discovery of objects made of exotic materials, things we can't explain using known ancient methods. If we ever find tools or containers made from advanced alloys, synthetic materials, or other strange substances, it could mean these objects were part of ancient batteries, power regulators, or energy converters. It's even possible that ancient electromagnetic or sound-based energy systems left a lasting mark on the Earth's crust. Over tens of thousands of years, those signals might have faded or been buried under newer activity, but some parts might still be detectable using modern instruments. For example, a strange repeating magnetic signal or a faint rhythmic vibration coming from deep underground could hint at a power system that once hummed with energy. If a highly advanced civilization had existed on Earth long ago and had created some form of communication network or data storage system, there is a chance that tiny remnants of that technology might still be hiding in the Earth today. These traces wouldn't be the usual things archaeologists look for, like broken pots, carved stones, or rusted tools, but rather subtle clues buried deep in the soil, rocks, or even ice. These clues could be in the form of strange chemical elements, unusual patterns in minerals, or mysterious materials that don't quite fit with what nature usually creates. Let's imagine, for example, that this ancient civilization had figured out how to use nanotechnology, tiny machines or particles far smaller than a grain of sand. If they used these microscopic tools to store information or send messages, they might have left behind materials unlike anything found naturally on Earth. These could include engineered particles, synthetic plastics, or even super-thin carbon sheets similar to modern-day graphene. Over time, such materials could become trapped inside layers of rock or mud, where they might remain for thousands or even millions of years. To find these ghostly footprints of lost technology, scientists are now using incredibly precise tools. One method involves looking for rare combinations of atoms, called isotopes, that wouldn't normally be found together unless someone had made them on purpose. For example, certain nanomaterials might contain strange mixes of metals or chemicals that stick out like a sore thumb compared to the usual makeup of Earth's crust. These chemical clues could be picked up using advanced machines like mass spectrometers or high-powered microscopes that zoom in on the atomic level. Some synthetic materials might even leave behind their own special fingerprints. For instance, a synthetic polymer or nanostructure might change the rocks around it by triggering new minerals to grow or causing chemical reactions that wouldn't normally happen. These changes can show up as weird shapes, unusual textures, or rare crystal forms that scientists can spot under electron microscopes. Even after many thousands of years, these odd formations could remain as silent witnesses to ancient technological activity. It's also possible that if the ancient civilization had used advanced ways to send messages, like electromagnetic waves or sound signals, some tiny physical traces of that technology could still be buried underground, For example, certain materials might hold on to faint magnetic or vibrational echoes, especially if they were designed to do so. These hidden messages might not be easy to spot, but with the right tools we might just pick them up. Of course, there are many obstacles in the way. Over long periods of time, natural forces like erosion, earthquakes, and chemical weathering can damage or erase evidence. There's also the risk of confusing recent pollution or industrial waste for ancient technology. However, scientists are getting better at sorting out what's natural and what isn't. With new and powerful tools, such as synchrotron radiation, nanoscale imaging, and isotope fingerprinting, researchers now have a better chance than ever of uncovering these ancient secrets. What makes nanotechnology and other advanced materials so special is that they often include very rare elements or complex molecular patterns. These don't just appear by accident in nature. If used on a large scale, whether through factories, dumping sites, or accidental spills, they could leave behind faint but telltale signs in the earth. These traces might show up in sediment layers, ancient mineral deposits, or even in ice cores drilled from polar regions. For example, an ancient society might have made nanoparticles with very specific atomic arrangements or covered them in protective coatings. These features could help them survive the passage of time, remaining locked within ancient rock layers for tens of thousands of years. In some cases, the materials might have turned into minerals themselves, forming completely new crystal types that don't naturally occur but can be detected by scientists through detailed chemical tests. The real challenge is figuring out which of these odd findings are the result of intelligent design, and not just nature playing tricks. To do this, researchers look for things that don't quite belong, like strange ratios of elements, unusual crystal shapes, or unexpected concentrations of rare metals. These might be hidden, faint, or buried deep, which means scientists need ultra-sensitive equipment to even notice them, and it gets more complicated. We also have to figure out if these clues are from ancient times or just leftovers from modern human activity. That's where a deep understanding of Earth's natural chemistry, geology, and environmental changes comes into play. Without that knowledge, we could easily mistake something natural for something artificial, or the other way around. But there's hope. As research advances, scientists are now turning their eyes to some of the most untouched and stable parts of Earth's geological archives. By studying the oldest and most well-preserved layers of Earth's crust, we may be able to pick out strange markers that hint at a forgotten technological past. This opens up exciting new possibilities, especially when we combine high-tech tools with remote sensing from space. Satellite imaging and remote sensing have changed the game. These tools allow scientists to scan massive areas of the planet, deserts, jungles, oceans, and mountain ranges, without having to set foot on the ground. From space, satellites can pick up subtle changes in soil color, mineral content, and surface heat. These changes might point to the presence of something artificial, like buried structures or leftover technology. Special cameras on satellites use multispectral and hyperspectral imaging, which can detect differences in light that the human eye can't see. These differences can reveal unusual materials or geometric patterns, like straight lines, right angles, or perfect circles, that are rare in nature but common in man-made structures. If scientists spot something odd, they can then send teams to explore those locations in more detail. Thermal imaging also plays a role. It can detect leftover heat or cold spots that may hint at energy use from long ago. In some cases, a patch of ground might still carry a thermal signature even after thousands of years, especially if strange materials were involved. But satellite data alone isn't enough. Earth is full of natural features that look artificial, like straight cliffs, polygonal rock formations, or oddly shaped lakes. This is why experts need to carefully analyze the data using advanced algorithms and machine learning. These programs help sort out real anomalies from natural lookalikes. One of the biggest challenges in the search for signs of ancient technology, possibly left behind by forgotten or even pre-human civilizations, is telling the difference between what is natural and what might be artificial. In other words, how can scientists tell if a strange-looking rock is just a natural mineral formation shaped over millions of years, or if it's actually a piece of something man-made like an old machine or tool? Nature has a way of creating complex and beautiful shapes all on its own. Over millions of years, things like heat, pressure, water, and even tiny life forms have helped shape rocks and minerals into patterns that sometimes look very much like they were crafted by intelligent hands. For example, layered rocks known as banded iron formations, or the fossilized remains of microbial mats called stromatolites, can appear as if they were designed or assembled. Some mineral veins form repeating patterns, straight lines, or symmetrical shapes that might trick the eye into thinking they're the remains of machines or tools. These formations usually come into existence through natural processes like the slow buildup of minerals from water, the movement of sediments over time, or even biological activity. But just because something looks artificial doesn't mean it is. Nature, it turns out, is a master sculptor. What makes this even more difficult is that mineral formations in nature can be incredibly diverse. Their shapes and patterns can vary a lot depending on the environment they formed in, such as how much heat or pressure was present, or what chemicals were around at the time. Because of this wide range of possibilities, it's very hard for scientists to create a fixed set of rules to clearly separate natural formations from possible artificial ones. On top of that, when looking at things like the makeup of minerals or the ratios of certain isotopes, which are versions of elements with different atomic weights, natural and artificial materials can sometimes look very similar. If a long-lost civilization had once used special minerals or processing techniques, those materials might now resemble something completely natural. Even more confusing, nature can occasionally produce strange and rare features, like crystal formations or tightly packed mineral balls known as concretions, that might seem like they were designed. There's another big hurdle. The tools scientists use today to find possible signs of past technology may not be powerful or precise enough. Technologies like satellite imaging, ground-penetrating radar, or spectroscopy, which looks at how materials reflect or absorb light, help researchers study what's beneath the Earth's surface or hidden within rocks. But many of these methods don't yet have the detail needed to spot tiny or subtle signs of artificial work, especially when they're buried in complex layers of natural geology. Telling apart a small artificial signal from a natural background pattern takes not just high-tech tools, but also a deep understanding of how the surrounding area formed. And often, this background knowledge is missing or unclear, especially in remote or ancient regions where layers of Earth have been building up for hundreds of thousands or even millions of years. All in all, the difficulty lies in three main things. First, nature's ability to mimic artificial designs. Second, the fact that natural and artificial materials can share similar features. And third, the current limits of technology. Solving this mystery will require not just better machines, but also a stronger understanding of how minerals and rocks form naturally. Only with that knowledge can we build reliable ways to identify true signs of ancient technology hiding in plain sight. But there is hope on the horizon. As our technology continues to grow more advanced, our chances of detecting long-lost signs of intelligent activity become much better. One of the most promising areas is in improving remote sensing, the science of studying Earth from a distance, usually using satellites or airborne tools. Newer, sharper satellite imaging systems can now detect tiny oddities on the Earth's surface, changes in shape, heat, or composition that might hint at artificial structures hidden under dirt, sand, or vegetation. These could include things like buried walls, strange shapes in the soil, or patterns that don't fit with natural geology. High-resolution spectroscopic tools, especially when combined with artificial intelligence and machine learning, can now process massive amounts of data and pick out unusual mineral mixtures or energy readings that probably didn't occur naturally. These smart systems can learn to recognize the difference between what nature typically does and what an intelligent hand might have done. Other important advancements are happening in geophysical surveys. Ground-penetrating radar, seismic tomography, which uses sound waves to see underground, and even magnetic resonance imaging are becoming more accurate and more affordable. These tools let scientists explore what lies deep below the surface without having to dig. They might be able to reveal buried structures, tunnels, or objects that have been hidden for thousands, or even millions, of years. Dating methods are also improving. New versions of mass spectrometry and radiometric dating can now measure the ages of rocks, bones, and other materials more accurately than ever before. This helps researchers build a timeline of events, when something was made, when it was buried, and whether it fits with known historical periods. If certain areas show signs of advanced material use or unusual energy consumption during a time when no known civilization existed, that could be a huge clue. Artificial intelligence and big data analysis are transforming how we search for these clues. By feeding computers large amounts of information about what natural formations usually look like and what artificial ones might look like, scientists can create smart systems that highlight possible artifacts or technological traces hidden in geological data. These systems can scan information from geology, chemistry, physics, and more, bringing together many different signs into a single, clearer picture. As all these technologies keep evolving, so too does our ability to explore Earth's deep past. It's possible that buried somewhere beneath the soil or locked inside ancient rocks are the secrets of civilizations that came before us. Perhaps thousands, tens of thousands, or even millions of years ago. These advancements won't just help us spot faint signs of ancient technology, they'll also help redefine how we understand intelligence and civilization itself. Over the years, many fascinating and thought-provoking theories have been suggested to explore a bold idea that intelligent civilizations might have existed long before humans ever appeared. These theories challenge the traditional belief that human civilization is the only one to have ever existed on Earth, and that we are relatively new in the planet's long and ancient history. Instead, these models invite us to imagine a much deeper past, possibly filled with lost civilizations, some even more advanced than our own. These ideas come from a wide mix of scientific fields, including geology, archaeology, evolutionary biology, and astrophysics. By combining knowledge from these different areas, researchers create detailed and believable scenarios of how intelligent life, either on Earth or on other worlds, might have risen, flourished, and then vanished without a trace. One of the most well-known theories is called the Silurian hypothesis. This theory suggests that a technological civilization could have developed on Earth millions of years ago, long before the first humans walked the planet. However, because of how Earth's geology works over long periods of time, with shifting continents, erosion, and sediment buildup, nearly all traces of such a civilization could have been erased or buried deep underground. If anything is left, it might be very hard to tell apart from natural features. For example, strange chemical signatures, odd patterns in isotopes, unusual mineral layers, or even fossilized machine parts might be hidden in the rocks, but we may overlook them or mistake them for natural processes. Another popular idea is that there may have been many different civilizations over the ages, each one rising to greatness and then collapsing, only to be forgotten by the next. This view suggests that civilizations might not be rare or unique at all. Instead, they could have come and gone across different geological periods, wiped out by disasters like volcanic eruptions, asteroid impacts, or massive climate shifts. These repeated cycles, combined with the slow but powerful forces of Earth like plate tectonics, may have completely erased the evidence of earlier technological societies. Some of these theories go even further by imagining civilizations beyond Earth, intelligent beings that may have lived on other planets or moons billions of years ago, long before humans existed. Thanks to studies in astronomy, scientists know that there are many other places in our galaxy where life could have existed. In fact, some planets might have had oceans, warm climates, and protective atmospheres billions of years before Earth was even formed. If life had time to evolve on those worlds, it's possible that intelligent civilizations could have developed and maybe even vanished long ago. When you look at all these ideas together, they stretch our understanding of civilization, time, and life itself. They show us that we need to think on much larger scales, not just thousands or millions of years, but billions of years, and not just Earth, but the entire universe. They also challenge scientists to improve their tools and techniques, to search for subtle signs of intelligence, no matter how ancient or hidden. But how do these models actually work? How do they connect all the complicated parts, like planets, living things, and technology? To build these models, scientists use multidisciplinary approaches, meaning they pull together ideas from different scientific fields to understand how civilizations might come into being, evolve, and disappear. First, they look at the planetary conditions that make life possible. This includes things like a stable climate, active geology, and the presence of an atmosphere. They also study how a planet's size, orbit, and magnetic field can protect it and support life over long stretches of time. Then they look at the biology. This part examines how life begins, grows, and survives challenges. They think about whether certain signs of life, called biosignatures, could still be found today, even after extreme changes like mass extinctions or climate disasters. Life doesn't just respond to a planet's environment, it also changes it. For example, plants and microbes can affect the atmosphere and climate, which in turn shapes the future of life on that world. These feedback loops can either help civilizations flourish or push them toward extinction. Finally, they study the technological side. This includes how long civilizations might survive, what kind of damage they might do to their environment, and whether anything they leave behind could be detected. For example, scientists wonder if we could ever detect ancient pollution in the atmosphere, unusual energy patterns or structures buried underground. They also consider the chances that a civilization might collapse due to war, environmental destruction, or running out of resources. Some may vanish quickly, leaving very little behind. By bringing all these pieces together, the planetary setting, the biology of life, and the rise and fall of technology, these models create a richer and more complete picture of how civilizations could live and die across the cosmos. They remind us that life and intelligence don't just depend on one thing, but on many different forces working together, and sometimes against each other, over cosmic timescales. These ideas change the way we think about habitability, the ability of a planet to support life. They show us that habitability isn't something simple or permanent. A planet could be perfect for life at one time and completely dead at another. Instead of thinking of habitability as a yes or no question, these models present it as a tapestry woven across time, where the right conditions might appear, disappear, and return again. One major takeaway is that many planets might be more suitable for life than we once thought, especially if life is good at bouncing back after disasters. If civilizations really did exist long ago, their ruins might still be hidden in ancient rock layers or scattered across the galaxy. This encourages scientists to look more carefully at the oldest parts of planets and moons, searching for faint signs of forgotten life. These models also challenge the idea that planets follow a simple, straight path in their development. Instead, they suggest that random and chaotic events, like asteroid strikes, supervolcanoes, or massive ice ages, might play a huge role in shaping whether life survives or disappears. Civilizations might rise quickly during peaceful times, only to fall just as fast when disaster strikes. This explains why we may not see any signs of them. They may have come and gone long before we knew how to look. In the end, these models help us understand how deeply connected everything is: the planet itself, the life it supports, and the technology that life might create. They suggest that the universe could be filled with life in many different forms and stages, some already gone, some just beginning, and others possibly far ahead of us. They make us question whether Earth's story is really so special, or just one chapter in a much larger book. These theories also offer new ways to think about the Fermi paradox, the famous question: if the universe is so big and life is probably common, then where is everybody? The model suggests that maybe advanced civilizations are rare, short-lived, or extremely hard to detect. Some might have destroyed themselves, others might have moved far beyond the kind of technology we recognize, and some might still be waiting to be found, hidden beneath rock, time, or space. One of the most fascinating ideas explored in these theories is how long a civilization can last, what scientists call technological longevity. According to these models, civilizations, whether they exist on Earth or far away in space, might not survive long enough to be noticed by others. They may collapse or slowly decline, not because of wars or invasions, but due to problems they create for themselves. These could include destroying their own environment, falling into social chaos, or simply reaching a point where technological progress slows down or even stops. If most civilizations tend to fall apart or fade away before they manage to send out strong, long-lasting signals into space, that could explain why we don't hear anything from alien worlds. In other words, the famous Fermi paradox, which asks why, in a universe so vast, we haven't found signs of intelligent life. might not mean the universe is empty. Instead, it might mean civilizations come and go too quickly to be noticed. They might burn brightly for a while, then vanish before anyone can hear them. These ideas also often mention something called the Great Filter. This is a name for the big obstacles that stop civilizations from reaching a point where they can travel between the stars or send signals across the galaxy. These filters could be enormous disasters, either caused by nature or by the civilizations themselves. Imagine supervolcanoes erupting, huge asteroids smashing into planets, or global pandemics changing the climate and wiping out entire populations. Events like these could destroy even the most advanced societies, setting them back or erasing them entirely. What makes it even more complicated is that such disasters might not happen just once. They could occur in cycles. Civilizations might rise, reach incredible heights, and then fall, only for new ones to appear later. But each one might last only a short time in cosmic terms. That would mean the chances of two civilizations existing at the same time and being able to talk to each other are incredibly slim. Some theories go even further, suggesting that certain civilizations might decide, either on purpose or by accident, to stay silent. They might avoid sending signals out into space to keep from attracting danger, or they might follow a belief system that tells them not to interfere with other life. This idea adds another layer to the mystery. If many civilizations are choosing to be quiet, and others are being destroyed by disasters, then it's no wonder the universe seems so silent. All these ideas come together to paint a picture of civilizations that are fragile and short-lived. The silence we hear in space might not mean no one is out there. It might mean that civilizations keep rising and falling before they ever get the chance to reach out. This perspective leads to deeper questions. What causes societies to rise or collapse? Could the same kinds of disasters that affect Earth also have destroyed other civilizations long ago? Many of these models focus on natural catastrophes as the turning points in the lives of civilizations. Throughout Earth's history, huge volcanic eruptions, asteroid strikes, or sudden changes in climate have reshaped the world. In these theories, such disasters are not just deadly, they are moments of transformation. When a disaster strikes, it can destroy entire cities, kill millions of people, and cause social systems to fall apart. Roads crumble, knowledge is lost, and the survivors are left to rebuild from scratch. But strangely enough, these disasters don't only destroy. Sometimes they clear the way for something new. A volcanic eruption, for example, might wipe out a civilization but leave behind rich volcanic soil that helps new farming communities grow. Climate changes can force people to move to new areas where they adapt and invent new tools or ways of life. So these disasters can act as both destroyers and creators, shaping the long-term path of human or even alien civilizations. How often these disasters happen and how severe they are matters a lot. If big catastrophes strike too often, then civilizations may never get the chance to build something that lasts. On the other hand, if they happen rarely but with great force, they could explain why some societies vanish suddenly from history. And when these disasters combine with other problems like running out of resources or civil wars, it becomes very hard for civilizations to survive for long. Another important point raised by these models is that the remains of ancient civilizations may not last forever. In fact, most traces of past societies are eventually erased by nature itself. Over tens of thousands, or even millions of years, wind and water wear down buildings, earthquakes and tectonic movements bury cities deep underground, and oceans rise to swallow entire coastlines. This makes it incredibly hard for archaeologists to find solid proof of ancient civilizations, especially those that may have existed long before humans. This leads to a very intriguing question. Could it be that the reason we've never found clear evidence of a pre-human civilization is because nature wiped away all the clues? If civilizations existed before humans, might their ruins now lie buried deep under the earth or lost beneath the sea? Some scientists and thinkers believe this is a real possibility. They suggest that these ancient civilizations might have used long-lasting building materials, or even built huge structures underground or underwater. These would be hard to find with today's technology. Others think that maybe they used special kinds of materials or lived in ways that didn't leave obvious marks, so their entire presence could be hidden within the rocks, chemical layers, or ocean floors. It's also possible that these civilizations were wiped out by disasters, giant volcanic eruptions, asteroid strikes, or sudden climate shifts that erased nearly all traces of their existence. These kinds of events might act like a global reset button, scrubbing the Earth clean and making it very unlikely that any solid evidence would survive to our time. Some theories go even further and suggest that ancient civilizations might have changed the environment in subtle ways, using advanced science, like bioengineering or climate control. These changes might leave strange patterns in soil or rock layers, things that scientists today might not recognize as artificial. They could look completely natural, even if they were actually made by intelligent beings long ago. Still, proving any of this is extremely difficult. One of the biggest problems is that we just don't have the right tools or methods to spot such faint ancient signs. The geological record, the layers of rock and sediment that hold Earth's history, is incomplete. Earthquakes, erosion, and other natural forces constantly shift, break, or erase these layers. Trying to find clues of a civilization from millions of years ago is like trying to find a single grain of sand in a desert. There's also the risk of making mistakes. If we find a strange rock formation, how do we know it's not just a natural creation? Could what looks like an ancient artifact be just a coincidence of nature? From a scientific point of view, trying to investigate the possibility of ancient civilizations that existed long before humans is extremely complicated. These investigations involve many different fields of study: geology, climate science, archaeology, and astrophysics, all working together. Each expert brings a different piece of the puzzle, but putting those pieces together can be very challenging. To figure out whether something strange in the geological record is natural or a sign of intelligent activity, scientists often have to look for indirect clues. These include odd chemical traces like unusual isotopes, mysterious patterns in microscopic structures, or strange layers of sediment in the ground. But interpreting these clues is still a work in progress. The tools and methods for understanding such signs are still being developed, and scientists have to be very careful not to let their personal beliefs or expectations influence how they interpret the evidence. This is known as confirmation bias, and it's a real danger in this kind of research. Another huge challenge is time itself. Some of these potential signs of ancient civilizations could be hundreds of thousands, or even millions, of years old. Trying to date materials that old accurately is very difficult, and understanding what was happening on Earth at that time makes things even more complex. Many dating methods lose accuracy as time stretches back so far, and events like erosion, earthquakes, or volcanic eruptions could have buried or destroyed valuable clues. From a philosophical angle, these ideas are even more mind-bending. They go against our deeply held beliefs that humans are the first and only truly advanced civilization on Earth, and that history moves forward in a straight line from primitive to modern. These theories make us ask deep questions. What counts as real evidence? Can we trust the tools we use to study the past? Is it possible that history is far more complicated than we ever imagined? They also force us to examine our own biases. One big example is anthropocentrism. This is the idea that humans are the most important and most advanced creatures ever to exist. This belief can make it hard for people to even consider the possibility that intelligent life might have existed long before us, or in ways very different from our own. Such biases can close our minds to possibilities that deserve real investigation. Because these theories are still very speculative, they often spark debates about what makes something scientific. One of the rules in science is that a good hypothesis must be testable. It should be possible to prove it wrong if the evidence doesn't support it. But when the evidence is extremely rare, very old, or hard to understand, this becomes a big problem. Still, the fact that it's difficult doesn't mean we should give up. Instead, it shows the importance of using careful, honest, and open scientific methods when studying such extraordinary ideas. Looking ahead, future discoveries could completely change the way we see these theories. New technologies are opening up exciting possibilities. Underwater exploration with powerful sonar, satellite images of hidden structures, and better methods for dating ancient materials might all reveal things we couldn't detect before. For instance, if sonar mapping of the ocean floor finds ruins that are clearly not natural and are older than any known human civilization, that would be groundbreaking. Or if scientists discover a layer of material filled with tools, carvings, or strange chemical traces and can show it's over 1 million years old, it might strongly suggest that another intelligent species once walked the Earth. On the other hand, these same technologies could also prove that no such civilization ever existed. If scientists search the ocean floor, deserts, and deep underground areas but find no clear evidence, no ancient cities, no advanced tools, no biological markers of a previous species, then it would support the current view that humans are indeed the first civilization to reach this level of complexity. Even if evidence remains missing, it might not mean those civilizations never existed. Earth is always changing. Wind, water, earthquakes, and other forces constantly reshape the surface. Over millions of years, whole continents have shifted, oceans have risen and fallen, and mountains have formed and eroded. These forces could have wiped out nearly all traces of ancient activity. But at the same time, some rare conditions, like volcanic ash covering a site, or deep-sea cold preserving an object, could have helped preserve clues, waiting for the right moment to be found. Environmental factors also add another layer of difficulty. Suppose scientists find a sudden spike in carbon dioxide, or strange particles in ancient air bubbles trapped in ice. That could point to a global event like a massive fire or industrial activity. But it could also mean a natural disaster, like a huge volcano eruption. Understanding the context is everything. The search for intelligent life beyond Earth, what scientists call SETI, short for the search for extraterrestrial intelligence, is not just about trying to talk to aliens living far away in space. It's also about the exciting possibility that alien civilizations may have already been here long ago and left behind clues we've yet to recognize. This idea fits with a fascinating theory known as the Silurian hypothesis, which suggests that highly advanced civilizations might have existed on Earth or elsewhere in the solar system long before humans came along, and they may have left behind traces of their existence that we just haven't noticed yet. So, the mission of SETI isn't only about listening for radio signals or laser flashes coming from distant stars, it's growing into something much bigger, like a cosmic treasure hunt. Scientists are now also looking for physical evidence, such as strange artifacts, mysterious structures, or unusual patterns in space that might hint at intelligent life from millions or even billions of years ago. For many years, traditional SETI work focused mainly on catching electromagnetic signals, like radio waves or flashes of light, that could have been sent on purpose by intelligent beings. But what if those alien civilizations rose and fell long before humans built radios or telescopes? Their broadcasts would have ended ages ago, making it nearly impossible for us to pick them up now. Because of this, researchers are starting to think that the best way to find ancient aliens might not be through signals, but through astroarchaeology, a kind of archaeology that looks not on Earth, but among the stars. One exciting idea is to carefully examine the surfaces of planets and moons in our solar system. If alien civilizations ever lived or visited these worlds, they might have built things or mined materials, and maybe even left behind giant structures. If scientists spot unusual shapes, perfect geometric patterns, or strange heat signatures that don't match natural processes, those could be signs of artificial activity. For example, if a planet has odd mineral deposits or looks like it's been dug into in ways nature can't explain, it might suggest that someone, or something, was working there a very long time ago. But the search doesn't stop at planets and moons. SETI researchers are also looking into the broader space environment for technosignatures, indirect hints of technology. These could be things like strange energy patterns in space, oddly behaving stars, or large objects that might be massive alien machines. One famous idea is the Dyson sphere, a giant structure built around a star to collect its energy. If such a megastructure was ever built, even billions of years ago, it might still be affecting the light or energy coming from that star in ways we can detect. There's even the possibility that artificial satellites or space probes from long-lost civilizations could be drifting quietly through space, maybe even right here in our own solar system. If intelligent life once tried to explore the galaxy, just as we are beginning to do, then bits and pieces of their technology might still be floating around, waiting for us to find them. In short, The modern search for ancient aliens has become a wide-ranging scientific effort. It now includes the study of old signals, space dust, planetary surfaces, strange metals, and even forgotten artifacts on Earth itself. Scientists are becoming more like space archaeologists, piecing together the ancient story of the universe and hunting for the faint clues that might tell us we are not, and never have been, alone. To detect signs of these ancient civilizations, scientists need to know what to look for and how to tell the difference between something natural and something artificial. Unlike loud and clear radio signals we might expect from living alien civilizations, the traces left behind by long-gone societies would likely be faint, hidden, or even decayed. They could be signals buried in the noise of space, or objects that have been damaged or buried over millions of years. One way scientists are searching is by looking for strange radio or laser emissions coming from specific parts of the sky. These could be leftovers from technology that once broadcasted messages, or just the glow of old machines that still give off energy. These emissions wouldn't be strong or obvious. They might come in bursts or be so faint that only the most sensitive instruments could notice them. Some might even be hiding among natural space signals like those from pulsars or quasars, making them very tricky to spot. Another way is to search for unusual structures on moons, asteroids or planets, structures that look like they were built rather than formed by nature. Maybe giant towers, grid-like formations, or mining areas that seem too orderly to be random. Such discoveries could point to intelligent design, perhaps for life support, energy collection, or even scientific experiments. These kinds of clues require powerful telescopes and imaging tools to explore far-off places and see what's lying beneath the surface. Scientists also study cosmic dust, meteorites, and ancient rocks that fall to Earth. If these objects contain materials that shouldn't naturally occur, like rare isotopes, strange metals, or unusual combinations of elements, it might mean they were manufactured by intelligent beings. Some of these might have crashed to Earth long ago and could now be buried in ancient rock layers, just waiting to be dug up and examined. And here's an even more astonishing idea. What if some alien artifacts are already on Earth, buried deep within our planet's ancient history? Imagine discovering a tool or structure that looks way too advanced to have been made by any known human civilization. Maybe a metallic object with a perfect shape, or an inscription using symbols that don't match any language we've ever seen. If such objects exist, they might be misidentified as natural, or simply dismissed because they don't fit what we expect. To truly recognize these clues, scientists must work together across many fields. Geochemists can test the chemical makeup of strange rocks. Materials experts can examine objects to see if their construction is too advanced for their supposed age. Archaeologists can investigate odd carvings or unexplained relics with fresh eyes. These experts must remain open to the possibility that some ancient mysteries could point not just to lost human cultures, but to visitors from far away. The problem is that unusual objects found in ancient sites can be easily misunderstood. People might think they're natural oddities or modern fakes, especially if there's no clear way to prove how old they are or where they came from. That's why it's so important to carefully test and validate these findings using the best science available. The idea that objects from other worlds might be hidden within Earth's ancient history is both exciting and mysterious. It invites us to take a fresh look at old archaeological discoveries, especially the ones that seem strange or don't quite make sense. Maybe, just maybe, some of these puzzling findings are more than just unusual human artifacts. This way of thinking encourages scientists to widen their point of view. Instead of only using tools from archaeology or history, they now bring in knowledge from space science, biology, and planetary exploration. When these different fields come together, it becomes easier to imagine that Earth's story could be more connected to visitors from space than we ever thought possible. Thinking along these lines naturally leads to a bold question. What if beings from distant planets visited Earth long ago? And what if they left behind clues, some of which we may have already found, but didn't recognize for what they really are? This is the heart of ancient alien theories. These theories challenge the usual explanations offered by archaeologists. They suggest that extraterrestrial beings, intelligent life from other worlds, might have played a role in shaping early human societies. Some even believe that these beings helped spark the birth of human civilization itself. From this perspective, researchers are encouraged to take a second look at strange artifacts, unusual structures, mysterious carvings, and odd symbols. Rather than brushing them off as myths or coincidences, some people argue that they might actually be evidence of contact with beings from other worlds. Imagine, for example, carvings that look far too advanced for their time or structures, built in ways that defy the known abilities of ancient cultures. Could these be messages from intelligent visitors, lost in time? This idea leads scholars to rethink everything. Maybe not all ancient objects were made by humans alone. Perhaps some were influenced or even created by extraterrestrials. When archaeologists come across artifacts that don't match the tools, knowledge, or culture of the people who supposedly made them, this new line of thinking offers alternative explanations. It also encourages teamwork across many fields: astronomy, geology, chemistry, and more, so that experts can study these mysterious findings from every angle. They begin to search for clues in places that archaeologists alone might overlook. Could some ancient materials, for example, have come from outer space? This brings us to something fascinating: the idea that space rocks, like meteorites and cosmic dust, might actually carry messages or materials from alien civilizations. Every single day, tiny particles from space fall to Earth. Some are as small as grains of sand, others are large enough to survive entry through the atmosphere and land on the ground. These pieces of cosmic debris are not just leftovers from exploding stars or wandering comets. They might also carry bits of technology, signs of life, or other clues from intelligent beings that once existed far away from our solar system. Meteorites, in particular, are especially interesting. They come from planets, moons, or asteroids that once existed elsewhere in the universe. When these space rocks land on Earth, they often carry strange chemical fingerprints or unusual atomic patterns. Sometimes, scientists find odd microscopic structures inside them, shapes that almost look like tiny machines or tools. This raises an exciting possibility. Could these be parts of ancient alien technology? For example, some meteorites have shown isotopes, forms of elements like nitrogen or helium that are not normally found in nature. These could point to some kind of artificial process, perhaps something designed by intelligent beings. And even though many scientists remain skeptical, some of these patterns have no clear explanation, making them worthy of closer study. Cosmic dust, though much smaller, is also worth investigating. These tiny bits of matter come from comets, asteroids, and even interstellar clouds far beyond our solar system. When collected and studied, they sometimes contain complex organic chemicals, strange mineral shapes, or traces of materials that are not known to form naturally. Some of these particles might even carry the building blocks of life, or fragments of long-lost alien worlds. With new technology like powerful microscopes, advanced lasers, and high-precision sensors, scientists can now study even the tiniest particles with incredible detail. They can measure the structure of atoms, detect unusual combinations of elements, and analyze patterns that might suggest an artificial origin. As this research continues, we may one day uncover stories hidden in the stars, stories of civilizations that lived, built, and vanished before we ever came into being. But the search for signs of ancient extraterrestrial life doesn't stop with Earth. Scientists are now turning their gaze to the skies. Modern astronomy provides powerful tools to help locate potential alien artifacts across the universe. This includes not only looking at stars and planets through telescopes, but also studying strange behaviors and mysterious signals in space that might suggest the presence of something artificial. One example is a star known as KIC 84628552, better known as Tabby's star. Astronomers noticed that this star sometimes dims in odd, unpredictable ways. This strange behavior led to speculation that something massive, like a giant artificial structure, might be orbiting the star and blocking its light, possibly a Dyson sphere, a theoretical megastructure designed by a highly advanced civilization to collect energy from a star. Instruments like the Wide-Field Infrared Survey Explorer, often called WISE, are able to detect heat given off by these kinds of hypothetical structures. If something huge were collecting energy from a star, it would give off a unique type of infrared light. So scientists carefully study these infrared patterns, hoping to spot signs of technology too advanced for natural explanations. Radio telescopes like those in the Allen Telescope Array also play a role. They search the skies for strange radio signals, especially narrow and repetitive ones that might be the product of intelligent communication rather than random noise from space. In addition to watching stars, researchers also study the surfaces and atmospheres of distant planets. By using special techniques like spectroscopy, they can look for elements and compounds that don't naturally appear under normal planetary conditions. If they spot something strange, like a material that requires advanced technology to create, it could be a clue that someone or something tampered with that world. Even the outer regions of our own solar system offer places to search. Scientists study the Kuiper Belt and the Oort cloud, which lie far beyond Neptune. If they notice patterns or arrangements of objects that look too organized or unnatural, it might be a sign of past alien activity. Telling the difference between natural events in space and signals that might come from intelligent life is one of the biggest and most complicated puzzles in modern science. The universe is full of powerful energy bursts and strange short-lived events that can easily look like they were made on purpose, even though they are probably not. The main reason this is so tricky is because many of the signals we detect from space are unclear or mysterious. Take, for example, something called fast radio bursts, or FARBs. These are super bright flashes of radio waves that last only a few thousandths of a second. At first glance, they might seem like messages sent from alien civilizations, but most scientists think they come from natural cosmic events, like two neutron stars smashing into each other, or violent flares from supermagnetic stars called magnetars. To figure out whether something like an FRB is natural or artificial, researchers must carefully study every detail, like the shape of the wave, how long it lasts, how often it happens, and even how the waves are polarized. One big problem is that the universe is wildly unpredictable. Many signals are one-time events. They just happen and never repeat. That makes them hard to study and even harder to label as alien or natural. Even regular signals can be misleading. For instance, pulsars, which are spinning neutron stars that send out perfectly timed radio pulses, were once thought to be alien beacons when they were first discovered in the late 1960s. But we now know they follow well-understood physical laws. On the other hand, signals that don't follow patterns might raise our curiosity, but still turn out to be caused by natural processes we simply don't understand yet. Another major challenge comes from our own limited technology. Even though radio telescopes and computers are getting better every year, they still might not be sharp enough to catch tiny details that would prove a signal is artificial. On top of that, the Earth is filled with noise, radio signals from human-made satellites, mobile phones, and even space junk. These signals can accidentally look like they came from aliens, fooling scientists and causing confusion. To make things even more complex, any alien civilization out there might be using a completely different kind of technology to communicate, something far beyond what we currently understand. Instead of radio waves, they might be using laser beams, neutrinos, or some other type of signal that we haven't learned to detect yet. If that's the case, we might already be missing messages simply because we don't know how to recognize them. So the real challenge is not just about building better tools, it's also about changing how we think. What does an intelligent signal even look like? How do we tell if something is just a strange cosmic event, or a message from another world? As we build better instruments and come up with better theories, scientists are slowly getting closer to being able to tell natural space signals apart from possible signs of alien technology. It's a long, careful process that sits at the edge of astrophysics and the ongoing search for extraterrestrial life, known as SETI. Looking ahead, future space missions might uncover even more exciting clues. These missions could lead to the discovery of ancient alien civilizations that once lived far beyond Earth. Thanks to new and more advanced technology, like high-tech spectrometers, robotic probes, and powerful remote sensing tools, we are now better equipped than ever to detect signs of life or technology on other worlds. For example, space missions headed to Europa and Enceladus, two icy moons of Jupiter and Saturn, are preparing to look beneath their frozen surfaces, where vast hidden oceans may contain the building blocks of life. If these missions find things like biosignatures, signs of living organisms, or even technosignatures, traces of past technology. It could mean that intelligent beings once lived beneath the ice of these distant moons. The planet Mars is also an important part of this search. Current missions are exploring ancient Martian riverbeds and lake beds to look for fossilized microbes, tiny life forms that might have lived billions of years ago. If we find complex organic molecules or other traces of biology, it could mean that life once existed on Mars, completely separate from life on Earth. That would be a huge discovery. Meanwhile, powerful telescopes are turning their eyes to planets beyond our solar system, called exoplanets. These telescopes are now good enough to study the atmospheres of faraway planets. Scientists are looking for strange chemicals such as artificial pollutants or unnatural lights, which could suggest that a civilization once lived or is still living there. Finding even a small clue like this would be a major turning point in human history. Another exciting idea is to look for actual alien artifacts. These could include enormous space structures, weird energy patterns, or strange signals that don't match anything we know. As our technology improves, searching for these kinds of remains becomes less like science fiction and more like serious science. It's possible that some advanced civilizations may have lived millions or even billions of years ago and left behind leftovers that we can still detect today, floating in space like cosmic ruins. Looking for evidence of civilizations that might have existed long before humans is not just a scientific quest. It's also an ethical and emotional journey filled with difficult questions. It makes us think deeply about how we study the past, how we respect other cultures, and how these discoveries could change what people believe about themselves and the world. As scientists search through layers of rock and ancient fossils, hoping to find signs of intelligent life that came before us, they carry a heavy responsibility. They aren't just digging into dirt, they're digging into the story of Earth itself, and what they find, or think they find, can have powerful effects. One of the biggest worries is about making mistakes. What if scientists find something unusual, like a strange pattern in a rock or a tool-like object, and too quickly claim it was made by intelligent beings? If they're wrong, it could confuse people, mislead the public, and damage the trust people have in science. That's why it's so important to double-check everything, to use clear and honest methods, and to avoid jumping to conclusions just for attention. Another major issue is how these discoveries affect people's beliefs. For hundreds and even thousands of years, many cultures have told stories about how life began and what makes humans special. If researchers find proof that intelligent life existed millions of years before us, it could shake those beliefs. Some people might feel threatened or deny the discoveries. Others might feel inspired, realizing that humans are just one part of a much older and bigger story. This could lead to new ideas about our place in the universe and help us feel more connected to the Earth and all life on it. But with such discoveries comes the need for respect, especially when it comes to ancient objects or sacred places. If something is found that might belong to a long-lost civilization, who gets to study it? Who decides where it should be kept, or whether it should be shown to the public? These are sensitive questions, especially for local communities or indigenous groups who may feel a deep spiritual connection to the land or the artifacts. Scientists must always work with care, listening to others and showing respect for different cultural values. There is also the danger of greed and exploitation. The excitement of finding ancient civilizations might lead some people to dig up sites without permission, or to sell artifacts for money. This can destroy precious evidence and erase the real story behind it. That's why it's so important to create clear rules and encourage international teamwork to protect these treasures. In short, searching for ancient, possibly pre-human civilizations brings up big and complicated questions. Researchers must be careful, honest, and respectful. They must protect the past, not just uncover it. After all, these discoveries could change how we see ourselves, not just as humans, but as part of a much longer and richer story that spans the entire history of life on Earth. If scientists one day found real proof that civilizations existed millions of years before humans, it would be one of the biggest discoveries in history. It wouldn't just change science books, it would change how people see themselves and their place in the world. For many centuries, people have believed that humans are the most advanced life forms Earth has ever known. We've told ourselves that we're the top of evolution's ladder. But what if we're not the first? What if other intelligent beings, maybe even high-tech societies, lived on this planet long before us? That idea alone would shake our understanding of history, and maybe even humble us a little. It might also change how we look at religion, mythology, and philosophy. Ancient stories about gods, lost worlds, and great floods might take on new meaning. Maybe those myths are memories of civilizations that really existed long ago. Religious teachings that focus on a single moment of creation might evolve into new ideas about cycles, life rising and falling over and over again on this ever-changing planet. This kind of discovery could also affect how we think about our own future. If other civilizations rose and fell long before us, what happened to them? Did they destroy themselves? Were they wiped out by nature? Could the same thing happen to us? These questions might make us more cautious about how we use technology and how we treat the Earth. On a deeper level, it could make us more open-minded. We might start to accept that intelligence and culture don't always look like ours. Civilizations could come in many forms, with different ways of thinking, creating, and living. This could help reduce narrow, human-centered views of progress and success. But then comes a hard question. Should we dig everything up right now? Or should we wait and protect these mysterious places until we're more ready? On one side, exploration is what drives science forward. Using tools like deep-sea robots, satellite images, and chemical scanners, scientists can look in places humans can't easily reach, like under the ocean floor, deep inside glaciers, or in remote deserts. These searches might uncover clues that were once invisible, traces of buildings, tools, or strange materials that don't belong in nature. Every new find helps us build a clearer picture of Earth's hidden past. But exploring comes with risks. Sometimes digging too quickly or without the right tools can ruin a site forever. Once the ground is disturbed, the original context is lost. And if something natural, like a weird-shaped rock, is mistaken for an ancient tool, it could lead to false stories and confusion. When the media gets involved, things can get even worse, with rumours spreading faster than facts. On the other hand, preservation means protecting these sites from damage. It means leaving them untouched so future scientists, with better tools and more knowledge, can study them more carefully. It also helps prevent misunderstandings and keeps the truth safe from being twisted or used for fame and profit. Most importantly, preservation respects the idea that some places may hold sacred meaning to others, and that we shouldn't rush to uncover things just because we're curious. Misunderstanding or exaggerating evidence about possible ancient civilizations that existed before humans can lead to serious problems, not just mistakes in science, but also confusion in society and even political or cultural tensions. At the heart of the issue is something known as confirmation bias, when people only focus on information that seems to support their own beliefs, while ignoring anything that doesn't. This often happens with unclear or incomplete data, which some researchers or storytellers may twist into dramatic tales. As a result, the truth gets lost, and both the scientific community and the public can be misled. When fragile clues, like strange rock formations or odd artifacts, are made to sound more important than they really are, they can create false ideas about history. These misleading ideas may pull attention and funding away from real scientific research. Even worse, they can weaken people's trust in science itself. Things get even more complicated when media outlets or online personalities jump in. They often turn uncertain findings into bold headlines, claiming they found definite proof of lost advanced civilizations. This kind of sensationalism makes things worse. It spreads confusion, fuels conspiracy theories, and creates unrealistic expectations. Then, when the exaggerated stories fall apart under careful study, people feel disappointed or betrayed, and they may stop trusting scientists altogether. But the impact doesn't stop there. These claims can also stir up deep cultural and political issues. For example, if someone says a forgotten advanced civilization once lived in a particular country or region, it could boost nationalist pride or create tension with other groups. On the other hand, if such evidence is ignored or rejected because it clashes with someone's religious or cultural beliefs, progress in science might be slowed down or blocked completely. Some religious groups, for instance, may see the idea of pre-human civilizations as a challenge to their beliefs about divine creation. A person from a Judeo-Christian background, for example, might see a strange fossil or rock formation as a sign from God, not as evidence of a forgotten intelligent race. Meanwhile, some indigenous communities may see those same clues as part of ancient spiritual traditions. In their view, those artifacts could be linked to wise ancestors or mystical beings, making them more open to the idea that humans might not be the first intelligent species on Earth. Cultural stories shape not only how people think, but also how scientific ideas are received. In places where governments control knowledge tightly, or where people don't trust science, unusual discoveries might be quickly dismissed. In contrast, in cultures rich in mythology, where stories of lost cities and ancient gods are common, people may be more welcoming of the idea that the Earth has a hidden past filled with mystery. These beliefs also affect how research is funded and how scientists talk about their findings. If a discovery threatens someone's core beliefs, it might face pushback or even be buried. But in communities that see science as a way to deepen spiritual understanding, those same findings might spark curiosity and open dialogue. That's why scientists must be very careful. When they speak about discoveries that could change how we see our past, they carry a great responsibility. They must communicate clearly, avoid exaggerating what they've found, and be honest about what is still unknown. If they present theories as facts too soon, it can cause confusion and mistrust. But hiding strange findings just because they are hard to explain isn't right either. It might block important breakthroughs. The best approach is to make sure every claim goes through careful checking, peer review, and thoughtful discussion before it reaches the public. This helps avoid mistakes and keeps science honest. Researchers also need to think about the wider effects of their work. Imagine if strong evidence appeared showing that a superintelligent species lived on Earth millions of years before humans. That could shake people's understanding of history, challenge national pride, and even disturb religious teachings. So, scientists must present their discoveries in ways that encourage thoughtful discussion instead of media frenzy. It's important that people learn from these discoveries, not fear them. It's also important for scientists to work closely with historians, archaeologists, and cultural leaders when interpreting findings. When new evidence hints at civilizations older than anything we know, the question becomes, who gets to tell that story? Care must be taken to avoid language that could create conflict between nations or groups, especially when dealing with sacred sites or indigenous lands. When scientists finally decide to share these big discoveries with the world, their goal should not be to shock or scare people, but to educate, inspire curiosity, and open minds. They need to use clear, thoughtful language that invites everyone to explore these mysteries together, while also respecting the cultures and beliefs that shape our world. As we dig deeper into the ancient past of our planet, scientists must act not only as explorers but also as guardians of truth, showing care, wisdom, and respect at every step. Finally, the discovery of civilizations that may have existed before humans raises a huge question. Who protects that legacy? If ruins or objects are found on land controlled by a country or tied to a specific group's history, disagreements may follow. Throughout history, control over archaeological discoveries has often led to battles over ownership, national pride, and cultural identity. Now imagine the discovery of something even older, evidence of a civilization that lived perhaps 10 million or even hundreds of millions of years ago. Such a finding could reopen old debates or spark new ones. Some people might use it to claim they come from a superior line of civilization. Others might feel their culture or religion is being threatened. When we talk about the Silurian hypothesis, we're diving into the fascinating idea that there might have once been an advanced civilization on Earth long before humans appeared, possibly millions of years ago, buried deep in the layers of rock and soil. If such ancient evidence exists, it wouldn't be sitting in plain sight like the ruins of Egypt or Greece. Instead, it could be locked away deep underground, hidden in stone that's been undisturbed for tens or even hundreds of millions of years. This raises the stakes in a big way. If scientists ever uncover strange artifacts, structures, or patterns that don't fit with our known history, things that might point to intelligent life long before us, people won't all agree on what it means. Some countries or cultural groups might say, "That's part of our heritage, it belongs to us." Others might say, "No, this is a discovery for all of humanity. Scientists everywhere should be allowed to study it. And if the discovery happens to be in a region that different countries are already arguing over, the situation could quickly get worse. Even worse, if these finds are seen as somehow threatening national pride or challenging a group's sense of cultural identity, emotions could flare up fast. On top of that, there's another layer of complexity: money. If these ancient sites lie in areas rich in natural resources, like oil, rare minerals, or even fossil fuels, companies might want to dig them up for profit. Others might see them as potential tourist attractions and try to turn them into businesses. This creates a conflict. Should we protect these sites for their scientific and cultural value, or should they be used to make money? Without clear global rules, this tug-of-war between conservation and profit could end up damaging priceless pieces of our past. To prevent fights and protect the value of these discoveries, we need a clear and fair set of rules that everyone agrees to follow. These rules should promote respect, teamwork, and openness. There are already examples of this, like the UNESCO World Heritage Agreements, which encourage countries to share responsibility for protecting important cultural and historical sites. We should build on these ideas. Involving local communities, scientists from all over the world, and even governments can help create trust. That way, no one feels left out, and the search for knowledge doesn't come at the cost of someone's culture or land. Imagine discovering real proof that intelligent civilizations existed on Earth before humans ever walked the planet. Such a discovery wouldn't just make headlines, it would completely change how we understand where we came from, what it means to be human, and where we might be going. For a long time, scientists have believed that the story of life on Earth is mostly a straight line, from simple creatures in the oceans to apes, and finally to Homo sapiens, modern humans. We've built this story on things like fossils, ancient tools, DNA, and the ruins of long-lost cities. It tells a neat, tidy tale of humans slowly becoming more advanced over millions of years. But what if that story isn't the whole truth? If we were to find signs of an ancient civilization that existed millions, or even hundreds of millions of years ago, long before humans appeared, everything would change. It would mean that humans might not be the first intelligent beings to build cities, create tools, or form complex societies. That possibility would shake our understanding of history to its very core. Such a discovery would force us to ask difficult and exciting questions. Are we truly unique, or just the latest in a long line of intelligent species? Have other civilizations risen to great heights, only to fall and vanish without a trace? If so, why did they disappear? Did they destroy themselves? Were they wiped out by natural disasters? Or did they just fade away, their knowledge lost under layers of rock and time? This would challenge one of humanity's most cherished beliefs, that we are the peak of evolution and progress. It would push us to think about intelligence, not as something only we possess, but as something that might have emerged many times before. Perhaps there were others who understood the world in ways we can't even imagine. Were they more advanced than us? Did they have technologies we've never dreamed of? Or did they live in harmony with the Earth in ways that made them wise but left behind little evidence? If we are not the first intelligent species on Earth, then perhaps our journey isn't as special or as secure as we thought. It would show that even highly intelligent life is fragile. Civilizations can rise, build wonders, and then fall, becoming buried under millions of years of history. This idea would give us a new perspective on our own future. If it happened before, could it happen again? Could we be forgotten, just like they were? It might also make us more humble. Instead of seeing ourselves as the only intelligent life to ever exist, we might start seeing ourselves as part of a much bigger story. A story that stretches across countless ages and includes many forms of life and consciousness. The effects wouldn't just stay in the world of science. They would ripple out into our cultures, religions, and philosophies. Many religions and belief systems teach that humans are special, even chosen. But what happens to those ideas if we're not the first? Would people lose faith? Would stories need to be rewritten? Or would we find new meaning in being part of a greater, more mysterious universe? Some ancient myths already speak of the lost civilizations, Atlantis, Lemuria, and others. These stories might take on new weight. What if they weren't just legends, but distant memories of something real? This shift in thinking might also bring people closer together. instead of dividing ourselves by race, nation, or culture, we might begin to see all humans as one family, one chapter in a much longer tale of intelligence on Earth. We might even start to feel a connection to those ancient beings, whether they were like us or something completely different. If ancient civilizations rose and fell before us, they might have left behind not only clues but warnings. Maybe they struggled with the same things we do: climate change, war, resource depletion, or uncontrolled technology. Their fate could help us understand the risks we face today. Could it be that every intelligent species faces a moment where it must choose between destruction and survival? If so, learning from the past might be the key to building a better future. This discovery might also lead us to think differently about what true progress looks like. Is it just about more technology, more power, and faster growth? Or is it about balance, wisdom, and long-term survival? Looking for evidence of ancient pre-human civilizations isn't just a fascinating idea, it's also full of ethical challenges. Digging deep into Earth's rocks and fossils could damage delicate environments or destroy the very clues we're trying to find. Scientists would need to be extremely careful. Every layer of rock, every fossil is like a page in Earth's diary. If we tear out those pages too quickly, we might lose the story forever. And if we do find something incredible, how should we share it with the world? Should we release everything right away, or take time to check, double-check, and think through the consequences? The discovery could shock people, challenge their beliefs, or even cause fear. That's why communication would need to be responsible, honest, and respectful of different cultures and worldviews. The idea that humans are not alone in Earth's long history isn't just a mystery, it's a doorway to amazing possibilities. It could inspire new ways of thinking, new kinds of science, and a deeper sense of wonder about life, time, and the universe. One of the most complex and fascinating parts of exploring the possibility of ancient civilizations, especially ones that may have existed long before humans, is how such discoveries could affect global politics. If we ever uncover strong evidence that an advanced civilization once thrived on Earth, tens or even hundreds of millions of years ago, it could shake the beliefs and national stories that many countries hold dear. Some nations might feel their cultural history is being challenged or even rewritten. Others might try to claim ownership of these discoveries to boost their political image or support certain ideologies. This is why it becomes incredibly important to make sure that the research is done fairly, transparently, and with the cooperation of scientists and governments from all over the world. The evidence must go through peer review, meaning other experts check the results carefully. International guidelines should be created to protect archaeological sites, and the rights of countries over their own land must be respected. Only through global teamwork can we avoid disputes and ensure that such groundbreaking discoveries are handled with care and honesty. But there's more than just politics at stake. If we really do find signs of ancient civilizations, especially ones that existed long before humans, we also need to think deeply about what this means for the future. How do we choose what parts of these discoveries to preserve? How should we interpret evidence that might not be very clear? Should all findings be made public, or are some things too sensitive to share right away? These are moral questions, and they don't have easy answers. Scientists will need to walk a fine line, searching for the truth while also being careful about how their findings affect the world. They must think about the environment, society, and the legacy they're leaving for the generations to come. As technology becomes more advanced, these ethical challenges will become even more important. The future of this kind of research depends not just on better tools but also on wiser decisions. Looking ahead, future scientific breakthroughs could completely transform our ability to detect and understand evidence from Earth's incredibly distant past. New tools are being developed that can look deeper into the ground and detect even the smallest signs that something unusual happened long ago. For example, scientists are now improving high-resolution isotope analysis, a technique that looks at chemical fingerprints in rocks and soil. This might one day reveal strange patterns that suggest industrial activity or technology, even if it happened millions of years ago and has since been buried or erased by nature. Other exciting developments include better microscopes and powerful methods like synchrotron radiation imaging. These tools might allow researchers to find tiny bits of material, such as special ceramics, rare metals or artificial composites, that could not have formed naturally. If discovered, they could be the silent witnesses of a long-lost civilization. New scientific fields such as astrochronology and advanced geophysical imaging are also beginning to play an important role. These approaches help scientists better understand the timeline of Earth's geological history. Enhanced seismic imaging paired with artificial intelligence could uncover hidden underground structures or objects that don't fit with what we currently believe about how Earth developed. In places that were once considered too harsh or too empty to support life, we might find proof that something intelligent was once there. Even more, as computers become faster and smarter, scientists can analyze enormous amounts of data more effectively. This will make it easier to spot patterns that were invisible before, like unusual spreads of certain elements across the planet that might point to old industrial processes. When we combine this information with climate models and data from ancient environments, we get a more complete picture of how early civilizations might have lived, thrived, and interacted with their surroundings. All these new tools won't just help us find more things, they'll help us better understand what we find. Being able to precisely date objects or match them to specific events in Earth's past will make it easier to tell the difference between what is natural and what might be artificial. Slowly, what once sounded like science fiction could become accepted science. Instead of guessing, we may finally build real stories, based on hard evidence, about the Earth's mysterious and ancient past. To make real progress in this search, we can't rely on just one branch of science. We need an interdisciplinary approach, where experts from many different fields work together. This is especially true for bold ideas like the Silurian hypothesis, which suggests that intelligent civilizations might have existed on Earth millions of years before humans and left only subtle clues behind. Geologists and paleontologists bring crucial knowledge. They study ancient layers of rock, chemical traces, and fossils that may hold evidence of past technological disruptions or sudden environmental changes. Archaeologists use advanced tools like ground-penetrating radar or satellite imaging to search for unusual objects or patterns buried deep in the ground. Climatologists help us understand how ancient climate changes could have affected early civilizations, while astrophysicists explore the impact of cosmic events, like asteroid strikes or solar storms, that could have left signs in Earth's crust. Even geneticists play a role by analysing ancient DNA to track biological changes that might be linked to intelligent societies, like the selective breeding of plants or animals. Working together, scientists from different backgrounds can develop better tools and sharper theories. By combining methods, like chemical testing with climate models, they can more easily tell the difference between nature's work and something created by intelligent hands. These collaborations open up new ways of thinking and help challenge old assumptions. With so many perspectives coming together, the risk of missing something important is greatly reduced. In short, interdisciplinary research is like assembling a giant puzzle. Each scientist adds a different piece, helping us slowly see the full picture of Earth's mysterious past. It also makes the final result stronger and harder to dispute. If we truly hope to uncover evidence of ancient civilizations, teamwork across many fields is not just helpful, it is essential. If it is ever confirmed that Earth hosted advanced civilizations long ago, it would dramatically change the way we care for and protect our planet. It would show us that complex life and intelligent societies are not new, and that our Earth may be much more dynamic and fragile than we ever imagined. Instead of focusing only on saving the forests and oceans we see today, we would also need to protect the deep layers of the Earth that hold precious records of our ancient past. One of the first changes would be an urgent effort to preserve geological records, layers of rock, fossils, and sediments that might still contain traces of these ancient civilizations. These records are like nature's library, and once destroyed, their knowledge is gone forever. New technologies would be created to monitor these sites carefully and to protect them from pollution, mining, or construction. Knowing that past civilizations may have altered the Earth's environment in big ways could also change how we view climate and nature. It might show us that Earth can bounce back from huge disruptions, or it might show us just how easily it can be damaged forever. Either way, the lesson would be clear. We must treat our planet with care and we should learn from the mistakes or successes of those who came before us. This new knowledge could also inspire countries to come together and agree on rules to protect Earth's history, much like how nations today have treaties about exploring space. These shared efforts would help prevent reckless behaviour that could destroy important archaeological or geological sites. More funding would likely go into research that connects geology, climate science, and archaeology so that we can better understand how past civilizations lived and what we can learn from them. However, confirming the existence of such civilizations would deepen our sense of duty toward the planet. Looking for signs of ancient civilizations that might have existed long before humans is a very difficult task. It brings huge scientific and technological challenges. Unlike human history, where we can often dig up buildings, tools, or bones that are only a few thousand years old, the clues to pre-human civilizations, especially ones that might have existed hundreds of millions of years ago, are likely to be buried deep underground, broken apart, or completely erased by natural forces. One of the biggest problems is the way Earth works. The surface of our planet is always changing because of things like earthquakes, volcanic eruptions, erosion from wind and water, and the slow but constant movement of tectonic plates. These processes can destroy or hide any evidence that once existed. Old rocks are melted down and formed into new ones. Mountains rise and fall. Oceans shift. If any advanced civilization ever lived long ago, their cities or tools could have been swallowed by the earth or ground into dust. Even the clues we can look for, like strange chemical fingerprints, unusual ratios of isotopes or rare materials, are often very hard to spot. For example, if an ancient civilization used metals or made synthetic materials, those traces might now look almost exactly like something formed naturally. That makes it hard for scientists to tell whether something was made by intelligent beings or just by nature. To even try finding such faint clues, we need advanced tools. Scientists use methods like high-resolution spectroscopy, deep earth drilling, and isotope analysis. But these tools have limits. Drilling into deep layers of the Earth is very expensive, and we can only search small areas. Earth's surface is enormous, and most of it remains unexplored at these depths. Another problem is time. Earth is about 4,500 million years old. That's such a long stretch of time that entire continents have disappeared and reformed. Any evidence from civilizations that lived hundreds of millions of years ago would have been through intense pressure, heat, and chemical changes. Over time, even strong materials like metal break down, and many signs would simply be erased or altered beyond recognition. The deeper we dig into Earth's past, the blurrier the picture becomes. Rocks from billions of years ago are rare, and the records they hold are often incomplete. Layers of sediment can be eroded or destroyed. Some may have been pushed deep into the planet by tectonic forces, while others might be missing completely. This makes it extremely difficult to put together a clear timeline or understand what might have happened. Even if ancient civilizations left behind machines, buildings, or other artifacts, chances are high that these objects would be broken into tiny pieces, buried, or chemically changed until they are almost impossible to recognize. For example, if a machine was made from a metal that reacts with water or air, it might have rusted away completely. Its remains could now be nothing more than a few specks of mineral dust. Chemical processes also play a role in wiping out clues. Water that moves through underground rocks can carry away or dissolve important chemical signs. Over time, materials left behind by a civilization might blend into their surroundings so well that they're indistinguishable from natural rocks. Even biological activity like plants growing or animals burrowing through the ground can disturb and destroy evidence. Microorganisms can eat away organic materials like wood or fabric. Unless something is buried quickly in the right conditions, like in a place with no oxygen, it probably won't survive millions of years. The Earth's sedimentary record, the layers of rock and soil that build up over time, is like a book that's missing most of its pages. What remains is scattered and uneven. That means if a civilization once existed in a place that hasn't been preserved well geologically, all evidence of them may be lost forever. Another issue is that we humans tend to view ourselves as the only, or the most important intelligent beings to ever exist. This kind of thinking, called anthropocentrism, can blind scientists to the possibility that a non-human civilization may have once existed. If we only look for signs that match what we expect to find, like steel tools or familiar types of buildings, we might miss entirely different forms of technology. Some scientists also assume that intelligent life is very rare. Because of this, they might not take the idea of ancient civilization seriously, or might avoid funding research into it. Others may unconsciously ignore strange findings that don't fit into accepted scientific ideas, a tendency known as confirmation bias. Even our scientific methods have limits. We rely on techniques like uranium lead or potassium-argon dating to measure the age of rocks. These methods are great for dating ancient minerals, but not always useful when looking for signs of technology. And even methods like thermoluminescence, which tell us when minerals were last heated, can be reset by natural events, making the results unreliable. Some of our best tools, like microscopes, spectrometers, and isotope scanners, can only do so much. They might miss tiny or deeply buried clues. They can also be affected by contamination or confusion between natural and artificial materials. All these challenges mean that even if we do find something unusual in ancient rocks, like a strange chemical or metal, it might be impossible to prove whether it came from a civilization or from a natural event. This is why scientists believe that working together across different fields is crucial. Geologists, chemists, archaeologists, paleontologists, and even astrophysicists must join forces. By combining their knowledge, they can better detect, interpret, and verify potential evidence. For example, a geologist might find an unusual layer in ancient rocks. A chemist could analyze its composition. An archaeologist could offer insights into how it might relate to structures or artifacts. An astrophysicist could consider whether a cosmic event, like a meteor strike, played a role in what's found. New technologies help too. Satellite imaging, for instance, lets us look for strange patterns in the ground from space. Machine learning tools can scan massive datasets to find hidden clues. And advanced scanning methods like synchrotron radiation or deep core drilling help us peek deeper into the Earth than ever before. These innovations have already helped refine our picture of Earth's history, and may one day reveal unexpected evidence of past intelligent activity. Scientists now look for strange isotopes, synthetic elements, or unusual structures that could hint at industrial processes. Some even search for signs of nanoscale technology or radiation damage that could point to ancient energy use. Even if we never find proof of ancient civilizations, the very act of searching pushes the boundaries of our knowledge and helps us understand more about our planet, ourselves, and our place in the universe.